The best way to prepare for the ESAT is by solving all of the available questions, and this is precisely what I've done in this video. We're going to start off with the 2016 Natural Sciences Admission Assessment. Okay, question 19, which is the first of the physics questions. In the 1920s, scientists discovered that the universe is expanding. One consequence of this expansion is that the intense gamma ray radiation that filled the early universe has now been shifted to the microwave region of the electromagnetic spectrum. Which line of the table describes how the expansion of the universe has affected the frequency and wavelength of these electromagnetic waves? So with the expansion of the universe, the wavelength has been increasing like this. So we can get rid of these answers like so. And because C is equal to F lambda, if the wavelength, increases, and the speed remains the same, then the frequency must decrease. So the correct answer here is B. Okay, question 20, what do we have? We have a nuclide 21482 changes by radioactive decay into the nuclei 21082. Which combination of emissions produces this change? So one alpha particle is a 4 and a 2, so if I had 3 of them, then the top number, this one over here, which is the amount of protons and neutrons, will actually change by 3 times 4, which is 12, but it's only changed by 4. So it's not going to be that. We know that there's going to be one alpha particle. Because there needs to be just one alpha particle, actually this means the correct answer needs to be D. And these time-saving tips are really important for the ESAT. Next one. So whenever we have questions like that on heat conductivity, the equation to remember is that delta Q over delta T is equal to K, which is just a constant multiplied by the area, change of temperature, and then divided by the length of the conductor. Okay, let's read this question carefully. In which case is the rate of conduction of thermal energy the same as the bar X? We kind of have to go for these one by one. So if it doubles, but then nothing else changes, well, that's not going to be it. This one here halves and there's no change, so it's not going to be it as well. This one here as well. Basically all of these are not going to work because something is bound to change if only one variable actually changes. Okay, out of these, E, there's no change in the area, there's no change in the length. If the temperature in T1 decreases by 10 degrees and the other one increases by 10 degrees, well, this here will end up increasing our delta T, so this here was not going to work as well. No change, only one variable that's going to change it. Okay, next one, no change, increases by 10 degrees, decreases by 10 degrees. Well, this one here is very similar to the previous one, so it's bound to be H in this case. Quick mental check, no change, increases by 10, increases by 10 as well. Yeah, that makes sense. Since delta T is just equal to T2 minus T1, if both of these increase by 10, the 10 and minus 10 will end up cancelling each other out. Okay, question 22. The graph shown of the quantity of y against x represents the motion of a body. Okay, which of the following could the graph represent? Kinetic energy for an object of mass 10 kilograms undergoing free fall. Okay, now for question 1, kinetic energy against velocity of an object. So KE is just equal to a half mv squared. So kinetic energy against velocity would mean that the gradient will be a half mv multiplied by v. Basically, this here is on the y-axis, this here is left for our gradient, and this here is on our x-axis. Well, if the object is undergoing free fall, the graph will not be a straight line through the origin because it will be accelerating. Therefore, this is not correct. Part 2, potential energy against height. So for 2, I'm just going to say PE is equal to mgh. This means that my gradient is going to be mg. So gradient is equal to mg. So we've got a 20 kilogram object, which is multiplied by g, which is 10. So we want our gradient to be 200, but our gradient is 5. So this here is also not going to work. Part 3, velocity against time for an object of mass 20 kg being accelerated by a resultant force of 100 newtons. So since F is equal to ma, A is equal to F over m, so this here will just be, well, 100 over 20, which is just 5 meters per second squared. Our gradient of the above graph is 5, and if it's a v against t graph, this here is going to be a correct option. Part 4, work done by an external force of 5 newtons. Well, for 5, we can say that work done is equal to force times distance. Work done against distance. Yeah, so if this here is on the y-axis, y is equal to mx plus c. Our gradient should be the force, which is equal to 5 newtons, and our gradient here was also 5. Therefore, 4 is also correct. So 3 and 4 are correct. Correct answer is F. Okay, 23. A uranium-235 nucleus can undergo fission to produce 2 smaller nuclei. Which of the diagrams, if any, could represent this process? Okay, so I feel that we probably need to check all of these numbers. So on the left, we have 1 proton and then 92 over here. So that's a total of 93. Over here on the right-hand side, we have 56 plus 36. Well, the proton number on the right-hand side is just equal to 92. So that doesn't check out, so it's not going to be this one. Diagram 2. Okay, so does this one work? What do we have? We have 92 on this side. On this side, we've got 54 plus 38. That also checks out, so that's 92. Okay, let's check out the other number, which is 235. Is that equal to, oh wait, 235, 1 plus 235, which is 236, because we have this neutron over here. Does that equal 137 plus 3 neutrons, which is 140 plus 96, which is also 236. So this one here checks out. Okay, diagram 3, 1 neutron and then 235. So that's 236 in total for the nucleon number on the left-hand side. Then we have 87 plus 145. So that's 232 plus 3, which is 235. So these are not equal to one another comparing all of the nucleon numbers. So it seems that it's 2 only, which is luckily an option. Okay, 24. A circuit consists of a 5 ohm resistor and a variable resistor connected in series with a 24 volt battery. The variable resistor has a minimum resistance of 3 ohms and a maximum resistance of 15. Okay, so I feel that I probably need to draw a circuit. So the variable resistor can either be 3 ohms or 5 ohms. In a series circuit, I want to have the maximum possible current to maximize the power. So if I want to find the maximum power dissipated in the 5 ohm resistor, I'm just going to use P is equal to I squared multiplied by R. So the resistance is going to be constant, which is just 5. Now, what is the current in the circuit going to be? The current is going to be equal to the total voltage divided by the total resistance, which is going to be 24 over 5 plus 3, which is 8, so it's going to be 3, so that's 3 squared times 5, which is 45 watts. Correct answer is D. 25, the diagram shows a 12-volt battery, a switch, and 3 resistors. Each resistor has a resistance of 30 ohms. Initially, the switch is open. What happens to reading on the ammeter when the switch is closed? Okay, so one of the things that you want to do is consider the resistances. So across this branch, when the switch is open, the current can flow through both of these resistors. So we can calculate our total, which is going to be 30 plus 30, which is 1 over 60 plus 1 over 30 raised to the minus 1. So this here will then be equal to 3 over 60 flipped, which is just equal to 20 ohms. Should we just figure out the current as well, because they're asking us what happens to current. So I'm just going to do this over here. Ammeter is here, so I is going to be 12 over 20. What is that? 0.6 amps. Okay, so this here is the first case. In the second case, when you close this switch, and this is really important, all the current is going to go through here because this here has no resistance. So we can assume that this, in the second case, that our 30 ohm resistor is gone. So that means we're just going to have 30 and 30 in parallel, which means that our R total is going to be half of 30, which is just equal to 15 ohms. And this is our second case. So the current then is just going to be 12 over 15, whatever that number is, 4 over 5, which is 0.8 amps. Okay, so what's happened to the actual current? It has increased by 0.2. You can also do a little mental check. Once you close the switch, you're no longer going through this resistor, so the total resistance ends up decreasing, meaning that the current must increase. So all of these answers kind of have to be wrong by default. But yeah, correct answer is E. Okay, 26, the total power radiated by a star is given by P is equal to KR squared T to the power of 4. Okay, the power currently radiated by the sun is 4 times 10 to the power of 26. So the radius increases by a factor of 100. Okay, so let's just be really careful. We're going to have 4 times 10 to the power of 6. And the radius increases by a factor of 100 squared. So that's the effect that it's going to have on the power. And the surface temperature will decrease by a factor of 2. So we probably want to divide this by a factor of 2 raised to the power of 4. So what is that? 4 times 10 to the power of 26 multiplied by 100 squared. What is that? 10 to the power of 30. And then we want to divide that by 2 to the power of 4, which is 16, like that. So I'm probably not going to finish the calculation because this here is just divided by a factor of 4. So it's fairly easy to finish the calculation. The answer is going to be 2.5 times 10 to the power of 29. What I was going to say is that once you realize that you have reached 10 to the 29, or the power is going to be 10 to the 29, there's no other answer which matches this power. 27, a transverse wave traveling from a medium has a frequency of 5 Hertz and a wavelength of 4 centimeters. And an amplitude of 3 centimeters. What is the total distance traveled by a particle of the medium in 1 minute? Okay, so the first thing that we need is the time period, which is equal to 1 over the frequency, which is going to be 1 over 5. So it's going to be, 0.2 seconds. So how many time periods there are in a minute? Well, 1 minute is 60 seconds. So let's divide that by 0.2, which is the same as 60. 2 times 10, which is what, 300. So there's 300 time periods. The total distance traveled by the particle is actually equal to 4 times its amplitude, because a particle first goes up, then it comes down, then after it's down to the equilibrium, it goes down to the negative amplitude, and then it sort of like comes back here. So it's going to be 4 times in one cycle of, it goes over the amplitude of 3 centimeters, 4 times. We are working in centimeters, and there's going to be 300 of them. So what is that going to be? 4 times 3 is 12. 12 times 300 is going to be 3,600 centimeters. 28. A motor is used to lift a mass of 5 kg using a pulley system as shown in the diagram. A pulley is secured to the roof using a coupling. The motor needs to cause the mass to accelerate upwards at 0.8 meters per second. What is the minimum tension force that the coupling must be able to withstand without breaking? So for these questions, I always tend to just draw out some of these vectors. So here's the tension going down and like so. So with the pulley effect, we're essentially going to get double the force pulling down. Well, what will that force of tension actually be? Well, if we just concentrate on this mass over here, the rope needs to be pulling it upwards with some tension T, and let's take away mg, and this thing here is going to have to be equal to ma. So T will be mg plus ma, so 5 kg, so it's going to be 50 plus 0.8 is the acceleration multiplied by 5. So what is that? 54 newtons. So now the minimum force that the coupling needs to withstand is actually going to be double that. So I don't know, let's call this force F. F will just be equal to 2T. So what's that? 108 newtons. Correct answer is H. Okay, 29. A heater is connected in series with a resistor and a 6-volt battery. Total resistance of the circuit is 15 ohms. In 3 minutes, 180 joules of electrical energy is transferred into other forms in the heater. How much charge flows through the heater in the 3 minutes, and what is the voltage across the actual heater? Well, for the charge, we can just use, equal to IT? Do we know what the current is? Well, we can figure it out pretty easily because we know that it's 16 volts divided by 15 ohms. Well, we can figure it out pretty easily because we know that the voltage is 6 and we know that the total resistance is 15. Well, this here is just equal to 2 over 5. What is that? 0.4. Now, if Q then will be equal to 0.4 multiplied by 3 minutes, which is going to be 3 times by 60, which is going to be 0.4 multiplied by 180. 4 times 180 is 720 divided by 10. That's equal to 72 coulombs. Okay, so we know that the charge is 72. How much and what is the voltage across the heater? Is it 0.4? Is it 2.5? Well, 180 joules of energy is transferred in other forms in the heater. So we can probably just use that voltage is equal to work done per unit charge. Well, all we need to do is do 180 divided by 72. The answer is not going to be 0.4, it's going to be 2.5, so correct answer is F. Okay, question 30. A cubic block has a hole through it with a square cross section. Dimensions are shown in the diagram. The weight of the block is 30 newtons. What is the density of the material from which the block is made? Well, let's see. So density is just equal to mass over volume. We know what the mass is. Can we figure out the volume? So we want the density of just the block. So the volume is going to be equal to 10 centimeters cubed. Take away the inside volume, which is gonna be 10 multiplied by the cross-sectional area, which is 5 squared. I'm just gonna keep working in centimeters cubed now. So what is that gonna be? 1,000. Take away 25 multiplied by 10, which is 250. So what is that gonna be? 750 cubic centimeters squared. Okay, perfect. The answers are actually in cubic centimeters, so we don't have to worry about converting them to meters. Okay, so density is just then equal to mass over volume. So the mass is going to be 3. I do have to worry about the grams though, because if the weight of the block is 30 newtons, assuming that G is equal to 10, the mass of it is 3 kilograms. So what is that? 3,000 grams. Divide that by 750. What is that going to be equal to? Well, that's exactly 4.0 grams per cubic centimeter. Correct answer is F. 31. The diagram shows 4 solid steel balls, P, Q, R, and S, which are of identical size. So P and R have shiny surfaces, Q and S have dull surfaces. We can see that these here are at room temperature. Which two balls lose thermal energy by convection? So convection occurs when we have a flow of energy between fluids, so something like air to a surface, for instance, or via a fluid. So P and Q are going to lose energy by convection. So we can get rid of pretty much all these answers. Which one has the greatest rate of thermal emission? So dark surfaces absorb and emit electromagnetic radiation most easily. So it's not going to be P and it's not going to be R. Question is it Q or is it S? Well, S has the higher temperature, so it's going to be emitting thermal radiation at a greater rate. So therefore, the correct answer is D. 32. Diagram shows the velocity time graph for an object traveling in a straight line over a period of 30 seconds. What total distance did the object travel in the 30 seconds? How far from its starting position was it at the end? And what was its average speed? Okay, so the total distance, we're going to need to figure out the total area underneath the curve. So what is this one here going to be? That's going to be the area, let's call it A1, is going to be a half multiplied by 20 multiplied by 8. So this here is just going to be equal to 80 meters. Right over here, on the other hand, we're going to have a half times 10 times 2, which is just going to be equal to 10. My mental maths is correct. So the total distance traveled is just going to be 90. Okay, so what about the distance from the starting position? Well, we can see here that the velocity has changed direction. So the distance would have been reduced. Here we would have gone 80 and then would have gone back another 10 in the opposite direction, so it's going to be 70. So we're between A and B. What is the average speed? They're asking us for the average speed, not the average velocity. So the average speed is equal to the total distance, which is 90 divided by the total time, which is 30. So 90 divided by 30 is just going to give us 3. Correct answer is A. Okay, question 33. Sample of radioactive isotope X decays to one other radioactive isotope Y. Y has a half-life that is double that of X. Initially, only X is present. Which graph could represent how the numbers of the nuclei X and Y present in the sample vary with time? All graphs cover the same period of time. Okay, so they're not going to be both decreasing at the same time, so we can get rid of E. Why is that? Because as X decays into Y, we expect Y to increase. So it's also not going to be B. Well, the numbers just don't seem to match up. So this one here has decreased by that amount, and then this one here seems to have increased even further. So we can scratch this one out. At a stage where there's still numbers of X over there, so I don't think that the correct answer is going to be C. D does not seem correct because here the numbers seem to have decreased quite a lot and Y has barely increased, so process of elimination, correct answer is going to be A. Okay, 34. Bronze is a mixture of tin and copper. A particular sample of bronze contains 10% tin by volume. So 10% tin, 90% copper. What percentage of the mass of the sample is tin? Okay, density of the tin is Y, density of the copper is X. So these are often done easiest just using with the fact that mass is equal to density times volume. So if we say that the total volume is 1, then the mass of the tin is going to be 0.1 multiplied by the density of the tin, which is Y. Okay, plus the mass of the copper, which is going to be 0.9, that was the volume, or the relative volume, multiplied by the density, which is going to be X. So this here is our total mass. So the percentage of the sample, which is tin, so tin was 0.1 y over 0.1 y plus 0.9x. So what does that equal to? Y over x plus 9, y plus 9x. Hopefully that's an answer. 9x plus y. Yep, correct answer is G. 35. When a stationary uranium-238 nucleus decays by alpha emission, it forms a nucleus of thorium-234. Total kinetic energy produced by the decay is E. So this question is done far more easily using p squared over 2m. So the thorium and the alpha particle will go up and down respectively with the same momentum due to conservation of momentum. So this p here will be a constant. How do the masses though actually differ? Well, the mass of the thorium is going to be 234 over 4. Why over 4? Because an alpha particle has is a 4, 2. Bigger with that ratio. The kinetic energy of the alpha particle for the same momentum And so the kinetic energy of the thorium for the same momentum will be smaller by that factor, which is 4/234. So we can say that the kinetic energy of the alpha particle plus the kinetic energy of the thorium is equal to E alpha plus 4/234 E alpha. This here is just the kinetic energy of the thorium expressed in terms of the kinetic energy of the alpha particle. This thing here is equal to E. We can say that E alpha 1 plus 4/234 is equal to E. E alpha 234 plus 4 is 238/234 is equal to E. E alpha is 234/238. E. Correct answer is D. Okay, a student carries out an experiment to measure the speed of sound. A loudspeaker that emits sound in all directions is placed between two buildings that are 128 meters apart as shown. The student and the loudspeaker are 48 meters from one of the buildings. Okay, so 48, so this distance here is going to be at 128 take away 48, which is just 80 meters. Okay, the loudspeaker is connected to a signal generator that causes to emit regular clicks. The student notices that each click results in 2 echoes, one from each building. The rate at which the clicks are produced is gradually increased from 0 until each new echo coincides with a new click being emitted by the loudspeaker. What is the frequency of the emissions when this click happens? Okay, so this here is probably the most difficult problem of the entire paper because it's actually quite difficult to visualize this. So, okay, the echo from the left wall should arrive at the same time when the echo from the right hand side arrives as well. And this in turn must coincide with a new click being emitted. So how long will it take for sound to travel there and back? Well, the speed of sound is 320. The total distance traveled there and back is 96. Divide that by 320. This here just gives us 0.3 seconds. On the other hand, we also have 160/320, which is the time it takes for sound to travel to this building and then back, which is, well, half a second or 0.5 seconds. So the actual click period must be divisible by 0.3, and it also needs to be divisible by 0.5. So 0.3 has to be equal to some number of sort of click periods, and then 0.5 also needs to be some number of click periods, where these here need to be integers, right? Because we're talking about distinct time periods. So probably the lowest possible common divisor is going to be when this here is 3t and this one here is 5t. In other words, the click time period is going to be 0.1, meaning that the frequency, which is 1 over the time period, is 1 over 0.1, which is equal to 10 Hertz. Correct answer is G. Okay, let's do the 2017 NSAA Section B, starting off with the first physics question, which is question 19. A car traveling along a horizontal road and straight line graphs a velocity time graph. During this part of the journey, what is the total distance that the car travels while it is decelerating? So the decelerating region is here. So all we need to do is figure out this total area. So let's have a look. We're going to have 20 multiplied by this distance. This is going to give us this area here, which is just going to be 20 times 20, plus this area, which is going to be a half, times 20 again, and the distance from here to here, well, that's just 10. Okay, so we have 20 times 20, which is 400, plus 10 times 10, which is 100. Correct answer is 500 meters. Question 20. When a saucepan of water is heated from below, convection currents form and transfer heat through the liquid. Here are three statements as the water is heated. Which of these statements help to explain how convection currents are formed? Okay, mass of the volume increases, density decreases, volume of the fixed mass increases. Well, this question is all about conservation of mass, because mass is equal to density times volume. The mass is not going to increase due to conservation of mass, so the first one is not really correct. The density of a fixed mass volume decreases. I would agree. So if we keep this constant, the volume will end up increasing, meaning that the density also increases, and those two statements here are correct. This here corresponds to correct answer being G. Okay, next one. The table gives the approximate frequency ranges of sections of the EM spectrum. Okay, we have quite a lot of information. Table 2 gives information about two different types of waves in the air. Quite a lot of information yet again. Speed of sound is also given. A person can detect only two of these waves unaided, just using their eyes and their ears. Which two waves does the person detect? Okay, well, the visible light range is anywhere between 400 nanometers to around 700 nanometers, which is like 7 times 10 to the power of minus 7 meters. So this means that we cannot detect this one, and we cannot detect this one. We can detect an EM wave of 500 nanometers, though that's roughly the color yellow. Okay, now a type of wave being longitudinal, which is just sound. Well, I remember that the maximum frequency that we can hear is around 20,000 hertz. So what wavelength does that correspond to? Well, lambda is equal to C over F. Speed of sound, we've taken it to be around 300 divided by 20,000 hertz. What is that going to give me? That's going to give me around 1.5 times 10 to the power of minus 2. So this here is the smallest wavelength that we can detect. It needs to be larger than this. So these here are going to disappear. This one here is fine. So 3 and 4 appear to be the only options. Correct answer is E. Question 22. A charge of 60 C passes through an electrical component when a steady voltage of 10 volts is applied across it for 30 seconds. Resistance of the component remains constant throughout. What is the resistance? Okay, so should we just use R is equal to V over I? This here is going to give me 10 volts divided by the current. Well, I don't really know what the current is yet, but I can just do Q over T, which is going to be 60 over 30. What is that? 2 amps. So this means that the resistance should be 5 ohms. Correct answer is E. Question 23. An electric motor is used to pull a broken down car slowly from the road up a ramp on the back of a breakdown truck. Car has a mass of 1,200 kg, falls to a vertical height of 1 meter. Anytime you see lifted for a vertical height, this here means use mgh somehow, and h is the vertical height against gravity. Total input energy is going to be equal to 28 kilojoules, and it's 75% efficient. The process of lifting a car, energy is lost to the surroundings. What is the total energy lost to the surroundings. So because we're looking for the total energy that's been lost to the surroundings, we need to start with the overall input energy around the output energy. So that means we can essentially ignore this. So I'm just going to do 28 times 10 to the power of 3, which is 28 kilojoules, and then from that I'm going to take away the energy that was required for this thing to be lifted, which is going to be 1200 multiplied by 10 multiplied by 1. This here is just mgh. Okay, so this here is 28 times 10 to the power of 3. Take away 12 times 10 to the power of 3, meaning the correct answer is going to be 16 times 10 to the power of 3, which is 16 kilojoules. 24. In one type of a medical scanner, a source is placed inside a patient's body. The source causes pairs of gamma rays to be emitted simultaneously in opposite directions. Detectors on each side of the patient are used to detect the gamma rays. The distance between the two detectors is 3 meters. Okay, so here is the patient. We have 1.5 meters here, 1.5 meters there. Okay, in a particular scan, the gamma rays arrive at the two detectors with a time difference of 4 times 10 to the power of minus 10. Assume the inside the patient, the gamma ray travels at a speed of 3 times 10 to the 8. How far from Q? Q is at the center, isn't it? So this here is Q, is the gamma ray source. Okay, so these types of questions are figured out using essentially that delta S is equal to V times T. Now, delta S is the difference in path lengths. And those questions typically involve a bit of a trick. Well, what is the difference in path length? So that's just going to be 3 times 10 to the 8, which is the speed, multiplied by the time, which in this case is just given to be 4 times 10 to the power of minus 10. So 3 times 4 is just 12, and then we have 10 to the power of minus 2, which is just 12 centimeters. Okay, so the idea here is that one ray travels a little bit more and another ray travels a little bit less. So I don't know, let's say that let's say that the gamma ray was emitted through here. We're going to have a total path difference of 2x because one ray travels x more, but then the other one travels x less in a way. So we can say that 2x is equal to 12. X is just going to be 6 centimeters. Hopefully that's an option. Correct answer is D. 25. When a plutonium-239 nucleus absorbs a neutron, it undergoes nuclear fission. What particular fission reaction results in the creation of xenon and something else as a daughter nuclide? The nuclear equation for this is shown. Which equation is correct? Okay, so for this one, all we need to do is a little bit of algebra, conserving the numbers. So we're going to have 1 plus 239, which is 240. I'm just conserving the nucleon number on either side. And this here is just going to be equal to W plus Y plus Z times 1, which is just Z. So W plus Y is not 240. That's not correct. Next one appears to be correct because Z is equal to 240 minus basically this. So yeah, this here is the correct answer. Another electric motor is connected to a constant 12-volt DC supply. The motor is used to lift a mass of 20 kg by means of a rope and a pulley. The mass is lifted vertically for a height of 6 meters in a time of 5 seconds. The complete lifting system is 80% efficient. What is the current in the electric motor? Let me show you a little bit of a trick. So let's just assume that it's 100% efficient. And if it's 100% efficient, power is equal to F times V. VI is equal to mg H over T. I will be mgh over T divided by the voltage, which is going to be 20 times 10. Height is 6, isn't it? divided by the voltage, which is 12, multiply this by 5. Notice how we have 10 times 6, which is 60, 12 times 5, which is also 60, so these here can go. So the current would be 20 amps if 100% efficient. But this is not 100% efficient, so the current needs to be higher. The only answer which is higher than 20 amps is 25, so this must be the correct answer. And if you wanted to, you could do a quick mental check that 0.5 times 25 is equal to 20 indeed. 27, the nuclide X decays to a stable nuclear Y. During the process, 4 particles are emitted. We've got an alpha particle and we have 3 beta minus particles. Which of the following is not a nuclei that could be formed at any stage during the process? I'm just going to underline the word any stage because this is really important for this question. So what is the effect of alpha and beta decay, this reaction? So if I have a nucleus which is PQ, if I have alpha decay, then what I'm going to get is this nucleus Y, which is going to be with or some other nucleus. I think it was Y in this question, but the important thing is that P will decrease by 4, and then Q will end up decreasing by 2 because an alpha particle is a 4 and a 2, right? So we have lost the alpha particle. Okay, now what is the effect of beta minus radiation? Well, in beta minus radiation, we have a neutron turning into a proton. So conserving charge, we actually get sort of 1, 1. So that means that we have a beta particle, which is just an electron, like this, to conserve the charge. We also get this antineutrino, which is not really relevant in this case. But the idea here is that during beta minus, a neutron turns to a proton. So this means that the effect of this is that we get a Q plus 1. So if we were to have just one of the alpha particles, so if we were to just have one beta particle, then we would get Q plus 1. If we were to have 2 beta particles, somebody will get Q plus 2. If we were to have 3 of them, we would get sort of Q plus 3. If we were to just have one alpha particle, we'll get P minus 4, Q minus 2. But what we definitely cannot get is Q minus 1, because if we have a single beta minus particle, this here will increase the atomic number. And if we were to have a single alpha particle, this will decrease the atomic number by 2. So A here is absolutely impossible. Correct answer is A. 20A, the radius of iron 56 is 3 times 10 to the power 4 greater than the radius of iron 56. So density of the atom of the density of the nucleus itself. Okay, so these questions are all about just making sure that we don't make a mistake in the actual fractions. So this here is going to be m over VA over m over Vn. What m is just the mass of the atom / the nucleus. We assume that they're exactly the same. Okay, so 1 over the volume, and I'm going to assume that I've cancelled 4 pi out of both equations because the volume of the sphere is 4 pi r cubed. So the volume of the atom is equal to 3 times 10 to the 4 times the volume of the nucleus, and this here is cubed. Divide that by, well, Rn cubed. Well, this here is, or 1 over Rn cubed. So this here is just going to be Rn 3 times 10 to the power 4 cubed. And then this here is cubed as well. And then we also have a factor of Rn cubed at the top. These here will just end up cancelling. So it will be R times 10 to the power 4 raised to the power of minus 3. Correct answer is A. Okay, question 29. Graph 1 shows the displacement of one of the particles of a medium, how it varies with time, the other one how it varies with distance. Which expression gives the speed in meters per second of the wave? Okay, well, V is equal to F lambda, so this is also equal to lambda over the time period. So let's start off with the wavelength. We know that this distance, which is x2 minus x1, if we look at it, that's half a wavelength, because this here is one full wavelength. So we can say that 2 times x2 minus x1 is equal to lambda. Now, what about the time period? Well, if we look at this, from here to here, it's one full cycle, one full time period. And then we can add another half a time period. So we can say that, well, t2 minus t1 is equal to 3/2 the time period. That, of course, means that the time period is equal to 2/3 t2 minus t1. Now I'm going to sub this into here, and then I'm going to sub this into there. Then I'm going to get that v is equal to 2x2 minus x1 over 2/3. So I'm going to get a factor of 3 here. t2 minus t1. Those cancel out. Correct answer is E. Question 30. A kettle is designed to work from a car's power socket. The kettle has a rating of 150 watts when a constant voltage of 12 volts DC is applied across this element. How much charge passes through an element of the kettle when the voltage is 12 volts and is applied across it for 20 minutes? Okay, so let's say that P is equal to IV. I'm going to go that I is equal to P over V, which is going to be 150 divided by 12. Let's leave this as a fraction. What is that? 50 over 4. Now, Q is going to be equal to I times T, which is going to be 50 over 4 multiplied by T, which is 20 minutes. Multiply this by 60 seconds. So this here will end up giving me 50 times 5 times by 60, which is 250 multiplied by 60. So 25 times 60 is 150. Correct answer should start with 150. So that means the correct answer is C. 31. A freight train traveling on a straight horizontal track at 2 meters per second collides with a passenger train traveling at 5 meters per second in the opposite direction. So this here is a question about conservation of momentum. Both trains immediately come to a stop on the track. So that means that essentially M1 V1 is going to have to be equal to M2 V2. Okay, so the freight train has 3 locomotives, 130 tons each. Okay, so let's say that M is going to be 3 times 130. And then it also has 7 containers of wagons, 30 each. It's going to be 7 times 30. And that's multiplied by the speed, which is 2. Okay, now M2 for the passenger train is going to be 2 locomotives of 70 tons each, which is going to be 140, plus a number of passenger carriages of 10 tons each. So let's call them X. So it's going to be X times by 10. So let's just call it 10X. And this here is the mass. Speed is going to be 5 meters per second. So now we've got an equation with a single unknown for x. Okay, so 3 times 130 is going to be 390 plus 7 times 30 is going to be 210. And each of this is sort of multiplied by 2. So this here will give us 600 times 2, which is 1,200, which is going to give us 140 times by 5 plus 500x, 1,200, 140 times this is 700 plus 500x, 1,200 minus 700 is, well, just 500. Oh, I spotted a mistake. 10 times 5 is just 50. So 500 is equal to 50x. X is just equal to 10. Correct answer is C. 32. Consider the following 4 calculations. Which 2 calculations result in the answer 40 kg? So this question is all about units. So first answer, 20 divided by 5 is 40 kilograms, meters per second divided by meters per second. Yeah, the first one is fine, no need to write that. Now, number 2, 20 joules divided by 5 meters. So 1 joule is equal to 200 kilograms meters squared s to the power of minus 2 divided by just by meters. So we're not getting rid of any of the seconds. This here is just not correct. 3, 200 kg m to the power of minus 3 divided by 5 m to the power of 3. No, we have to divide by minus 3 if you want to give if you want to get rid of this. So this here is not correct. 200 newtons. Okay, well, a newton is gonna be kg ms to the power of minus 2. If we divide that by ms to the power of minus 2, we get kilograms. This one here is fine. So 1 and 4, correct answer is C. Consider the following 3 statements about a parachutist of mass 72 kg falling vertically at a constant velocity of 5 meters per second after the parachute is opened. The parachute has a constant kinetic energy of 1,800. Okay, so parachute is open, they're moving at a constant speed. What is their energy going to be? It's going to be a half times the mass, which is going to be 72, times the speed squared, which is going to be 25. So what is that going to be? 36, so multiply this by 25. So 36 times 20 is going to be 7,200 plus 36 times 5. Well, this here is not going to be 1,800 joules. In fact, it's 900. It's a lot smaller than that. Number 2, the parachutist is losing GP at a rate of that. Because the parachutist is moving at a constant velocity, we can just use power is equal to FV, where this here is the rate. F is just going to be mg, which is going to be 72. Multiply this by 10, multiply by the speed, which is 5. What is that going to give me? So 72 times 5 is 360. Multiply this by 10. It's going to give me this many watts. So number 2 is fine. Air resistance and the force of gravity acting on the parachutist are Newton's third law pair of forces. Absolutely not. The other pair for the force of gravity is the force from the parachutist on the earth. Okay, 34. This is a tricky one. 2 radioactive sources, X and Y, have half-lives of 3 and 2 hours, respectively. The product of the decay of both these sources is a stable isotope of element Z. 6 hours ago, a mixture contained the same number of atoms, both X and Y, and no other atoms. What fraction of the mixture is now made up of atoms Z? Okay, so the first thing to notice is that here we've got a half-life of 3 hours, so that means that 2 half-lives have actually elapsed. So that means that we are going to have X minus X 2 half-lives, which means that it's halved twice, which is 2 to the power of 2, which is 4. So this here is going to be 3 over 4 X Z atoms. The other one is how many Z atoms are we going to have from the element Y. So for Y, we've had 3 half-lives. So we're going to have Y over 2 to the power of 3. We're halving 3 times, so over 8. So this here is going to give me 7 over 8 Y Z atoms from Y. Okay, so what is the mixture going to be? Well, the total mixture is going to be 3 over 4 X plus 7 over 8 X, 7 over 8 Y, excuse me, divided by X plus Y. Now, when you're dealing with some of these mixtures, just pick an easy number. I'm going to set just x is equal to y, which is going to be equal to 10. This should give us the correct answer. So this here is going to give me 3 over 4 times 10 plus 7 over 8 times 10 divided by 20. What is that going to give me? 30 over 4 plus 70 over 8 divided by 20, which is going to end up giving me 60 over 8 plus 70 over 8, divide that by 20, which is going to be 130 over 8, divide that by 20. And this here is 130 over 160, which is 13 over 6. Correct answer is D. 35. Car X passes car Y on a motorway. Car X is traveling 1.5 times the speed of car Y. The mass of car X is 4 over 5 the mass of car Y. How do the kinetic energies of the two cars compare? Okay, kinetic energy of car X is, well, we're going to need to calculate this. So the easiest way that I would do this is I'm just going to say X is basically a half mx Vx squared, but each of them is related to y. So this here is going to be a half. The mass is 4.5 my, and the speed is going to be 1.5, which is 3 over 2. So squared, we're going to get a factor of 9 over 4 Vy squared. So then we're going to get a half times 4.4 over 5. Actually, let's bring the 4 over 5 outside of here, and we're going to get 4 over 5 times by 9 over 4 times by a half my Vy squared, which is, this bit here is just Ey. So 4 times 9 over 5 over 4, this here is just going to be 36 over 20. This means that Ex is going to be 36 over 20, which is 1.8 Ey. I'll just write it over here. This here corresponds to answer E. In the following circuit, the ammeter shows a reading of 4 amps. The power dissipated in the 12 ohm resistor is 12 watts. What is the power dissipated in the 4 ohm resistor? Okay, the first thing I'm going to do is just calculate the total resistance, which is going to be 1 over 4 plus 1 over 12 raised to the power of minus 1, which is going to be 3 over 12 plus 1 over 12 raised to the power of minus 1, which is going to be 4 over 12 flipped, which is 12 over 4, which is going to be 3 ohms. So this here is just the equivalent resistance. I can probably calculate the total power, which is just going to be equal to I squared multiplied by R, because I've got the current, don't I, which is just 4. So this here is going to be 4 squared, multiply this by 3, which is 48 watts. Now, power slash energy has to be conserved, so if I have 12 watts across here, across this one, I'm going to have 48 take away 12, which is just going to be 36 watts. Correct answer is E. Okay, let's do the 2018 paper. Starting off with the first physics question, which is question 19. An unstable nucleus X becomes a stable nucleus Y after a succession of decays during which a total of 5 alpha particles and 2 beta minus particles are emitted. How many fewer protons does nucleus Y contain than X? Okay, so what is the effect of emitting a total of 5 alpha particles? Remember, an alpha particle is a 4 and a 2. So if we were to emit 5 of them, then we're going to lose 5 multiplied by 2, i.e. a total of minus 10 protons, and that's just from the alpha particles. Additionally, though, we have 2 beta minus particles emitted. If we have a beta minus particle, a neutron would have turned into a proton. And if a neutron turns into a proton, because this thing here is a 1 and a 0, 1, we get a beta minus particle being emitted. So 2 of them would mean a plus 2 protons because, well, 2 neutrons would have turned into 2 protons. Overall, that gives us 8. Correct answer is B. Okay, question 20. The diagram shows 3 resistors R1, R2, and R3 connected in series with a battery of constant voltage. Resistance of each resistor and the corresponding current are also shown. Okay, resistor R3 is then removed and the circuit is reconnected. Well, the first thing that we want to do is we want to calculate the total EMF. So the total EMF will be given by IR, which is going to be 0.2 multiplied by the total resistance, which is going to be 12 plus 15 plus 3. 12 plus 3 is 15, so this here is just 30. So 0.2 times 30 is just going to be equal to 6 volts. Okay, so the new current in the circuit is just going to be V over R, which is going to be 6 over the new total, which is just going to be 12 plus 15, which is going to be 27. So it's going to be 2 over 9, which is going to be 0.22 amps. Correct answer is B. 21. When traveling in a vacuum, visible light has a wavelength between 400 and 700 nanometers. Speed of light in a vacuum is 3 times 10 to the power of 8 meters per second. What can be concluded about ultraviolet radiation from this information? Okay, so let's just calculate some thresholds. So in order to have ultraviolet, our wavelength needs to be below 400 nanometers. So it has a maximum wavelength of 400 nanometers. So if our wavelength is max, that means that this is going to correspond to a minimum frequency. What would that minimum frequency be? Well, F is, let's call it F min, is equal to C over lambda, which is going to be 3 times 10 to the power of 8. Divide that by 4 times 10 to the power of minus 7. This here will be 3 over 4 times 10 to the power of 15. 3 over 4 is like 0.75 times 10 to the power of 15. Correct answer is G. 22. There's a couple of different ways of solving this one. It's a speed time graph, and we're looking for the average speed. So the classic way is to use the fact that average speed is equal to total distance divided by the total time, and the total distance will just be given by the area of this, which is going to be, what is it, a half times by 20 times by 12, which is this area here, plus 12 times 60 plus a half times 12 times 40, like that, divided by the total time, which is 120. You can do this. This will end up giving you 1080 over 120, which is 9 seconds. There is a slightly easier way as well. You can also look, and this only works for straight lines, by the way, but let's take the mid value, and we can say that over here the average is 6, just over this region, and as a proportion of the whole thing, this will be 6 20 over the whole thing, which is 120, plus this over here, which is 12 times the speed is just 12, doesn't change, over 60 over 120, which is just a half, plus this region over here, which is going to be 6 times 40 over 120. And this here, if you were to calculate it out, it is simpler to simplify, and my guess is that this is the method that they were probably pushing you to try and use. 9 seconds, correct answer is E. Next one, a filament lamp working at its operating voltage converts electrical energy at a rate of 100 watts, has an efficiency of 5%. How much energy is wasted by the lamp in 10 minutes? Okay, well, let's just use that energy is equal to power times time. So the power is 100, multiply this by the time, which is 10 minutes, so it's going to be 10 multiplied by 60. So that's 1,000 times 60, which is going to be 60,000. Now, how much, that has an efficiency of 5, how much energy is wasted? So 95% of it is going to be wasted, so we just want to find 0.95 multiplied by 60,000. Don't try and calculate that, look for a number which is just a little bit below 60,000. Correct answer is E. 24. A student is investigating heat flow along a solid uniform metal bar. The bar has length L, etc., etc. Which relationship represents the rate of flow? Okay, so once again, we're just going to use that delta Q over delta T is equal to Ka T2 minus T1. This here is just the general equation. And if you do a bit of spotting, you're going to see that this here corresponds to answer C. The only difference is that T1 and T2 are swapped, but this is because they're just trying to confuse you. They've just told you that T1 is the greater temperature, so therefore the temperature gradient is actually T1 minus T2. But yeah, correct answer is C. 25. The potential difference across the motor in an electric car is 400 volts. The current in the motor is 1250 amps. The car accelerates along a horizontal road from rest for 4 seconds. The efficiency of the overall system is 45%. What is the kinetic energy of the car at the end of the 4 seconds? Okay, well, let's work out the energy transferred, which is just going to be equal to VIT. So what is that going to be? 400 volts, multiply this by 1250, multiply this by 4 seconds. So what is that? 1,600, multiply this by 1250. A little bit tricky to calculate, but I can do this as 2 times 800 times 125, and then I can go 8 times 125. Well, that's just equal to 1,000. Then we had a 2, and what we're left with is just some zeros, right? So 1, 2, 3. So this here is just equal to 2 million. 45% of that, just 45% of that is just under a million, i.e. 900,000 joules. Correct answer is C. 26. The momentum of a small object moving in a straight line is 24 kg ms to a minus 1. Its kinetic energy is 96. What is the mass of the object? Okay, so what you should use is the formula that kinetic energy is equal to p squared, where p is momentum, over 2m. So the mass is equal to p squared divided by 2 times the kinetic energy. So what is that? 24 squared over 2 times 96. Okay, so this here is going to be 24 times 24 over 2 times 96. Okay, so that's going to be 24. 12 divided by 96 just gives me 8. So it's going to be 24 over 8, which is just 3. Correct answer is A. 27. This one here contains a standard trick. A radioactive isotope decays in a single step to a stable isotope. A radiation detector is placed very near to a sample of radioactive isotope in the lab. What is the background rate and what is the half-life of the isotope? Okay, so this constant value here is the background count rate. So this is obviously just going to be 20. So we can get rid of these options over here. What is the half-life? So imagine that we subtract 20 if we were to redraw this graph ending at 0. This point here will no longer going to be 120, it's actually 100. And the moment it halves is not going to appear on this graph as 60, but in fact is going to appear as 50 plus 20, which is what is going to be 70. So 70 is just going to be just between 60 and 80, which is, I believe, somewhere just over here. Yeah, so correct answer is A. Background count rate is 20, half-life is 40. 28. A rock falling vertically experiences an air resistance force of 12 newtons at an instant when its acceleration is 2 meters per second squared downwards. What is the mass of the rock? Okay, so here's the rock. We have mg acting downwards. It is going to be bigger because the rock is accelerating downwards. So we're going to go mg, take away the drag, is equal to mass times acceleration. G minus MA is equal to D. Mg minus A is equal to D. M is going to be equal to the drag, which is 12 over G minus A, which is, let's take G to be 10. Take away the acceleration, which is 2. So this thing here is just equal to 12 over 8, which is equal to 3 over 2, which is 1.5, which means the correct answer is C. 29. A transverse wave with an amplitude of 4 centimeters and a frequency of 10 hertz travels along a rope at a speed of 2.4 meters per second. What is the total distance traveled by a particle in the rope in a time of 20 seconds? So with those types of questions, the first thing I probably do is just work out the time period, which is just equal to 1 over the frequency, which is 1 over 10, which is equal to 0.1 seconds. Then I work out how many cycles has the wave actually been through. So I can do 20 over 0.1, and this here is just going to give me 200 cycles. Now in one cycle, each wave is going to go 1 up, 1 down, then it's going to go 1 down again and 1 up. So that's 4 separate amplitudes in one cycle. So that's going to be 4. The amplitude is equal to 4 centimeters, which is 4.0 times 10 to the minus 2. Just be aware that this is in centimeters, this here is in meters. And that has happened 200 times, like that. So what is that going to be? Okay, so it's going to be 2 times 4, which is going to be 32 meters. Correct answer is E. Question 30, this is a tricky one. Student places a measuring cylinder on a balance. She pours a volume V of water into the measuring cylinder and finds that the mass of the measuring cylinder and the water together is 290 grams. She then empties the measuring cylinder and dries it before putting it back on the balance. She now pours the same volume of olive oil and finds that the mass of the measuring cylinder oil together is 270. Okay, so the same volume seems pretty important. What is the mass of the measuring cylinder? Okay, so let's just call the mass M. I'm going to say that we're given density, so we're going to have to use density times volume is equal to mass. I'm going to say that the mass of the cylinder plus the density of the water times the volume is going to be equal to 290. So that means that M is going to be, 290 minus rho V. Now, additionally, we can do the same equation, but with the olive oil. So we're going to go M plus, let's call rho 2V is equal to, 270. So that means that M is going to be 270, take away rho 2V. Okay, so what we can do now is just set those equal to one another and then figure out the volume, hopefully. So 290 minus rho V is equal to 270, take away rho 2V. 20 is equal to rho, take away rho 2, multiply by V. 20 is equal to 0.1 V. This means that V will be 20 over 0.1, which is going to be 200 cubic centimeters. Okay, now we can go back to either of those two equations. I'm going to put that into here. So M will be 290 minus the density of water is just 1 gram per cubic centimeter. So over 200, this here just gives me 90 grams. In other words, correct answer is C. 31, a skydiver of weight 1,000 newtons falls vertically. We've got a distance time graph for the skydiver is shown. The air resistance F acting on the skydiver traveling at velocity v is given by the following equation. F is equal to kv squared. K, what is the numerical value of k for the skydiver? Okay, so a terminal velocity mg is equal to kv squared. This means that k will be mg over v squared. So it's going to be 1,000 because 1,000 newtons divided by whatever speed we're actually dealing with. So what will the speed actually be? Well, it's going to be a gradient, so let's just pick a couple of numbers which are relatively easy to deal with. So I'm going to go between 100 and, I don't know, 300, pick a whole value. So this here is equal to this value, which is 2 squares just above 4. And this one here, it's equal to, well, also the same, about 2 squares over 8. So they're going to differ by 4 seconds. So what is that going to be? 204. 200 over 4. And then this here is a square. Let's not forget. Okay, so this here will then give me 1,000 multiplied 4 squared we're going to get on top, which is going to be 16. Divide that by 200 squared. Okay, a bit of mental maths, as here is going to be 16,000 over 4, and then loads of zeros. Okay. Okay, 32. I really like this question. A source generates water waves of fixed frequency that have a wavelength of 1.5 centimeters. As they cross a boundary into shallower water, the frequency does not change, but their speed is reduced by 18 centimeters per second. New wavelength is that. What is the speed of the waves in the shallower water? So if the frequency doesn't change, we can say that, let's say F1 is equal to F2, where F1 is in the deeper, F2 is the second one, which is the shallower one. So if the frequency is the same, that means that V1 over lambda 1 is equal to V2 over lambda 2. So one of the things that we can probably do is just rearrange for, let's say, V1. So V1 will be V2 multiplied by lambda 1 over lambda 2. But then we also know that the speed is reduced by 18. So we know that V1 take away V2 is 18 centimeters per second. So let's say that V1 is actually equal to V2, lambda 1 over lambda 2, take away V2, and that's just equal to 18. Now, V2 times lambda 1 over lambda 2 is going to be 1.5 over 1.2. Take away V2 is equal to 18. 1.5, this is just 15 over 12. 15 over 12 is going to be 5 over 4. Take away V2 is 18. Okay, so what is that going to give? That's going to give me a quarter of V2 is equal to 18. V2 is going to be 18 times 4, 72 centimeters per second. Correct answer is E. 33, a neutron is absorbed by a uranium-235 nuclide. Okay, the resulting nuclide undergoes fission to produce bromine, 8835, and lanthanum-145 nuclide and some neutrons. How many neutrons are emitted in the fission reactions? And then we also know how many protons there are in this element. Okay, so this thing is all about conserving numbers. Initially, we have uranium-235, so let's just consider the atomic mass separately. So if we have initially 235 plus an extra neutron, we're actually going to have 236. So all of this gets transferred to, well, 88 from the BR and 145 from this one. So 236 is going to give me 88 plus 145, which is 2, 3, 3. So that means that in order to balance them out, I'm going to need 3 extra neutrons. And those are the extra neutrons that will end up being emitted. So we can get rid of quite a lot of the answers like so. Okay, now the next bit is, so what else is asking for? How many neutrons are emitted? How many protons are there in the nuclide formed by the decay of lanthanum-145? Okay. So we need to consider the protons as well. Initially we had, 92. And then we also had 35 over here. So that gives us 57 to play with. But then the whole thing undergoes beta minus decay. So if it goes beta minus, a neutron, an extra neutron would have turned into a proton, which means that the 57 here will end up turning into a 58. So what does that mean? Correct answer has got to be H. 34, the diagram shows a circuit containing a battery and 3 identical resistors X, Y, and Z. Total power supplied by the battery is 18 watts. What is the power dissipated as heat in resistor X? Okay, so if the resistors are identical, I'm probably going to just redraw the circuit as 2 in series, where this one here gets R/2, this one here has resistance of R. So it has half the resistance, so that means that this parallel branch with X and Y will have half the power. So how much power is it going to have? And also, why does it have half the power? Well, because P is equal to I squared multiplied by R. I is a constant in the parallel branch and the other resistor Z, because the current is the same. So half the power will be a direct consequence of having half the resistance. So that means that the power is going to be in a ratio of 1 to 2. You can say that x plus 2x essentially is going to be 18, which means that 3x will be 18, meaning that x will just be 6 watts. So this means that this here is going to get 6 watts, this one here is going to get like 12 watts. But out of those 6 watts, they're going to be split evenly between those two because they have the same resistance. So therefore the the power dissipated in resistor X is going to be even half of that, so it's going to be 3. In other words, we have 3 watts across here, 3 watts across here, total of 6, and then we have 12 watts across here, a total of 18. 35, a filament lamp and 0 to 10 ohm variable resistor connected in series with a power supply of constant voltage. The graph shows the voltage current characteristic of a filament lamp when the resistance of the variable resistor is 4 ohms and the current of the lamp is 2 ohms. What is the power dissipated in the lamp when the resistance of the variable resistor is set to 0? Okay, so let's just draw a little circuit. Here's our lamp, like so, and here's our resistor. So what do we know? The resistance of this guy is 4.0 ohms. The current in the lamp, and hence in the circuit as well, is 2. So that means that this one here is going to have 8 volts. If we have 2 amps, we are going to get, well, 6 volts across here. So that means that our EMF is going to be 14. So, okay, we're getting somewhere. Now, if we were to set the variable resistor to 0, then we are going to have exactly the same voltage across the lamp, which is going to be 14. 14 is right over here, and that's going to correspond to a current of 3 amps now. Note that the resistance of the lamp is most likely not constant, it's very nonlinear. So we can just use P is equal to VI, which is going to be 3 times 14. What is that? 42. The answer to everything. Correct answer is E. 36. 3 detectors X, Y, and Z are separated by large distances. Each of the detectors records a seismic wave Each of the detectors records a seismic wave from the same earthquake whose epicenter is very close to the surface of the Earth. Wave travels out at 4 kilometers per second. Detector X and Y detect the wave at the same time. Detector Z starts to detect it a minute later. Which of the following statements must be correct? The epicenter is the midpoint of the line XY. Or let's just draw a little drawing. Let's say this here is X. Let's put, I don't know, Y here somewhere. But I don't know, let's put like Z over here. Well, the first one is not necessarily correct because yes, it's true. It could be like right over here, but I mean, it could also be somewhere over here, right? And then it might travel the same distance to X, Y, and Z. And this one here says it must be correct. So it's not necessarily correct. 2, Z is equidistant from X and Y. I'm gonna go with no. I mean, it could literally be pretty much anywhere on the circle. Detector Z starts detected a minute later. So yeah, I don't see why this should be correct. 3, Z is no more than 240 kilometers away from X and Y. Okay, so this here is not correct. Z is no more than 240 kilometers away from the epicenter. This here should say epicenter, if I can spell this. Why is that? Because it's 4 times by 60, which is a minute, is 240 kilometers. So this here is essentially the differences in path of the wave from the epicenter to Z, but not relating it to X and Y. So this is one of those questions in which I'm going to go for A, which is none of them. Okay, 2019 paper, question 19. A transverse wave is traveling through a medium. The distance between successive wave peaks is 8.4 centimeters. So this here is actually just the wavelength, and the total distance traveled by one particle during one oscillation is 5.6. What is the amplitude and the wavelength of the wave? So this here usual trick, it relies on the fact that the particle is going to travel up, then down again, then back up. So that is 4 amplitudes in one oscillation. So the amplitude will be equal to 5.6 divided by 4, which is the same as 7 over 5. What is that? 1.4. So the amplitude is 1.4, and the wavelength, well, that's just going to be 8.4. Correct answer is B. Question 20. A builder lifts bags of cement onto the back of a lorry. Each bag has a mass of 25 kg. It takes the builder 2.5 minutes to load 10 bags. What are the total work done to you on 10 bags and the average power required for it? Okay, so to lift one bag, we just need to overcome mgh, which is going to be equal to 25 times 10, which is 250. Multiply this by 1.5, which is going to be 25 plus half of that, which is going to be 25 plus 125, which is going to be 375. Now, let's multiply this by 10 to get 3750 for 10 of these bags. Okay, so the answer should be either one of those two. Now, which one exactly? Well, the power is going to be 3750 divided by the time, which is 2.5. Multiply this by 60. So this here is going to be a relatively small number. It's definitely not going to be 1,500. So I'm going to bet that it's 25. Correct answer should be E. 21. The current voltage graph for a diode is shown. Okay, the diode is connected in series with a resistor and a 6-volt battery. So let's just draw this really quick. I find that really helpful for electricity questions. Here is my diode like this, connect positive to negative. Okay, the current in the circuit is 8 milliamps. So that's going to go through pretty much both of them. What is the resistance of the resistor? Okay, so when the current is 8 milliamps, where is that going to be? Here. That means that the voltage across the diode is going to be 1.2. So this one here is 1.2 volts. How much is left? Well, it's going to be 6 minus 1.2, so it's going to be 4.8 volts left across this one. Okay, what is the resistance of the resistor? Well, we can just use R is equal to V over I, which is going to be 4.8 divided by 8 milliamps, which is 8 times 10 to the power of minus 3. Okay, what is that going to be? It's going to be 0.6 times 1,000, which is going to be 600 ohms. Correct answer, hopefully that's an option, is F. 22, 2 EM waves P and Q travel in a vacuum. The ratio of the wavelengths is this much. Rich row in the table shows the ratio of the speeds. Okay, so if they travel in a vacuum, they are EM waves, so they all travel the same speed, which is the speed of light. So the ratio is going to be 1. So we can get rid of those answers. Okay, which shows the ratio of their speeds and the ratio of their frequencies. Okay, so if the ratio of the wavelength is around 10 to the power of 8, that means that they need to be in pretty far sort of differences in terms of the spectrum. So microwaves and radio waves are not going to work because they're really close in terms of, they have a massive overlap, or pretty close in terms of their wavelengths and frequencies. Infrared and ultraviolet, maybe, but still the difference is not going to be as much, and visible light and infrared are pretty close. Because the wavelengths differ by 10 to the power of 8, I am going to say that the correct answer must be A. So a microwave is typically a few millimeters, maybe a few centimeters. An X-ray is about the size of an atom, which is around 10 to the power of minus 10, around about 10 to the power of 8. Correct answer must be A. Question 23, we have a block of aluminium of mass 0.8 kilograms, initially at a temperature of minus 21 degrees C, supplied with this much of thermal energy. We're given the specific heat capacity, we're looking for the final temperature. I always find that useful to just calculate delta T and then apply that rather than calculate T2 immediately. So delta T is going to be equal to E over MC, which is going to be 54 times 10 to the power of 3 divided by the mass, which is 0.8 kilograms. Multiply this by the specific heat capacity, which is going to be 900. Okay, let's see what that actually gives us. So shall we just divide 54 by 9? What is that going to give us? That's going to give us 6, and then 100 here. So at the top, we're going to have 6,000, or 6 times 10 to the power of 3. At the bottom, we're just going to get 80, which is the same as 3 over 4. Multiply this by 100, which is 0.75 times 100, which is 75. Okay, so change of temperature is 75. So if we're going from minus 21 plus 75, we are going to get 54 degrees C. Correct answer is C. 24. A light spring is used to support a range of loads. The springs obey Hooke's law. System is in equilibrium. Which of the following is correct? Tension. The spring is directly proportional to the length of the spring. Nope, that's incorrect. To the extension. Tension in the spring and the weight of the load are Newton's third pair of forces. This is incorrect. Anytime you have the weight, the other sort of Newtonian partner is the force from whatever it is on the Earth itself. 3, when the extension of the spring is doubled, the energy stored increases by a factor of 4. Yeah, that is true. Why is that true? Remember, EK is equal to a half kx squared. 3 only is the correct answer. 25, we have a watertight cylinder with a thin, freely moving piston contains this much of trapped air at atmospheric pressure of 10 to the power of 5 pascals. When the cylinder is submerged in water of constant density, that the volume of air in the cylinder decreases to 4 times 10 to the power of minus 4. Piston is a depth h below the surface, and the water surface is open to the atmosphere. What is the depth h? Okay. So all of this happens, it says, assumes that the temperature is constant. If the temperature is constant, this means that we can write immediately that P1 V1 is equal to P2 V2. Now, there is a bit of a trick here, and anytime you're dealing with atmospheric pressure added up on top of some sort of a piston pressure or something like that, in this case P2 is actually equal to the atmospheric pressure, which was 10 to the power of 5. So we can just say that P2 will be 10 to the power of 5 plus rho GH, whatever that sort of fluid actually was. Okay, so the first thing that we need to do is actually find out our P2. So P2 will be P1 V1 over V2, which is going to be 10 to the 5 atmospheric pressure multiplied by the initial volume V1, which is 2 times 10 to the power of minus 3 divided by V2, which is 4 times 10 to the power of minus 4. Okay, so we can do carefully a little bit of cancellations. And at the top, we're going to get 10 to the power of 2, or 100. And at the bottom, what is it? 2 times 10 to the power of minus 4, whatever that is. So this here is going to give us 10 to the power of 6 over 2, which is the same as 0.5 to the power of 6, which is 5 times 10 to the power of 5. Okay, now this here is our P2, but remember this here is a mixture of the atmospheric pressure plus that additional pressure at a depth h. So I'm going to say that P2 is equal to, well, atmospheric pressure, or P1 or P, whatever you want to call it, plus rho GH. Rho GH is equal to P2 minus atmospheric pressure. Now P2 was 5 times 10 to the power of minus 5. Atmospheric pressure was equal to 1 times 10 to the power of 5, so I'm just going to get 4 times 10 to the power of 5. What am I looking for? The height, which is going to be equal to 4 times 10 to the power of 5 divided by rho multiplied by g, which is going to be 1,000 multiplied by 10 plus 1,000, wasn't it? Yeah. Oh, this is going to cancel out nicely. So at the bottom we have 10 to the power of 4, the top. So h is just going to be 40 meters. Correct answer is A. 26. The secondary coil of an ideal 100% efficient transformer is connected to the resistor by cables of total resistance 1,500 ohms. Current in the primary coil is 4 amps. There are 240 turns in the primary coil, 4,800 turns in the secondary coil. What is the power produced as heat in the cables? Okay, let's just write down some equations. So V1 over V2 is equal to N1 over N2. We don't have a lot of voltages though. Remember, the equation is flipped for the current, so it's going to be I2 over I1. We can probably work out what I2 is, which is going to be N1 over N2. Multiply this by I1, which is going to be 240 over 4,800 in the secondary coil, multiplied by the initial current in the primary coil, which is 4. Okay, so that's going to reduce quite drastically. What is that going to give us? Well, this here is a 1. It's going to give me a 2. The 2 and this here can cancel. So we're going to get 2 at the top multiplied by 10 divided by 100, which is going to be 0.2 amps. Okay, we have the current that I'm just going to use P is equal to I squared multiplied it by R. Current was 0.2 squared multiplied by the resistance, which is 1,500. Okay, how do we evaluate this? I'm just going to do 1,500 times 0.2 times 0.2, which is the same as 4 over 100. Okay, these here can go. 50 times 4 is just 60. Okay, so 60 watts, correct answer should be A yet again. 27. Heat is supplied to an initially solid substance at a rate of 60 watts. The graph shows the variation of the temperature of the substance with time. What is the mass of the substance? Okay, so we can see that we have no temperature scale, so we can't really use E is equal to MC delta theta, but that's okay. We're just going to use E is equal to ml. The mass will be the energy divided by the specific latent heat, which is going to be power times time. So what is the power? It's going to be 60 multiplied by whatever time we have. So somewhere here to about there. What is that? From here to here is 40 plus another 5, so we'll call it 45 divided by the specific latent heat, which is 100. Okay, so 60 times 45, what is that? So 60 times 40 is 2,400. 5 times 60 is 300, so 2,700. Divide that by 100, 27 grams. Correct answer is E. 28. We always do these questions by looking at the equation that delta Q over delta T is equal to Ka delta T divided by the length L. What's interesting about this question, though, is that for which of the following conditions is the thermal energy conducted along the bar at the lowest rate? So we want to minimize the flow of heat energy. To minimize this, we want this length here to be the largest. So we're probably going to set the L to be like 0.8. So it could be some of those. We want to set the area to be the lowest, which means that we want the diameter to be the lowest, which is going to narrow it down even further. And we want to make sure that there's as small of a temperature gradient as possible. Because here it's 90 degrees, we're going to have a greater temperature gradient if we picked E. So therefore, we're going to pick 40 to minimize T as well. Correct answer is F. 29, a U-shaped permanent magnet rests on a balance. We've got the length of the wire, current of 2 amps, and the reading of the balance is 202. You reverse the direction, the reading changes to 198. Okay, so that means that every time you flip the direction of the current, you are essentially with this experiment measuring the weight of the actual magnet. So if it fluctuates between 202 and 198, then we can take the force that's been added onto it to be the equivalent of the weight of 2 grams. So the weight of, 2 grams is 2 times 10 to the power of minus 3. Okay, so then we're going to multiply this by 10 as well to actually get the force. So we need to work out the strength of the magnetic field. So B will be equal to the force divided by IL. So the force will be 2 times 10 to the power minus 3, multiply this by 10, which is going to be what? 2 times 10 to the power of minus 2. Divide that by the current, which is 2. And then what do we have? We have the length, which is, where's the length? 5 centimeters. 5 times 10 to the power of minus 2. A lot of cancellations. What are we left with? We're left with 1/5, which is 0.2 Tesla. Correct answer is C. Question 30. The radioactive isotope X becomes the stable isotope Y after a succession of decays involving only emission in alpha and beta minus particles. Okay, during the emission, the decay of one of the nucleus, a total of 7 particles are actually emitted. It's known that more of these particles are alpha than beta particles. Okay, the atomic number of X and Z is the mass number of X is A. Okay, which row could give the atomic number? Okay, which row is correct, basically? So, the first one has a mass number of Y. So the mass number essentially gives us the number of alpha particles. So because an alpha particle is just a 4 and a 2, if the mass number has changed by 12, and this here is the mass number, that means that we would have had, in the first case, 3 alpha particles, but also that means we would have had 4 beta minus particles, which just doesn't work because they're telling us that there's more alpha particles that's being emitted. So this one here is not going to work. The next one is going to correspond to, so it's 8, so that's going to be, well, how many alpha particles is that? That's just going to be 2 alpha particles. Let's just write sort of in terms of alpha particles. Next one is going to be 5 alpha particles. Next one is going to be, 6 alpha particles. This one here is going to be 4 alpha particles. Okay, so this one here will also not going to work because that means that there's 2 alpha particles, going to be 5 beta particles, which we can't have. The next one, if we have, so now we need to check the Z number of the remaining possible options. So if we were to have 5 alpha particles emitted, the atomic number should change by a factor of 10. Okay, but then it will also change by yet another 2 because each beta minus particle will change it. So it's this means that the answer should be C because each beta particle emission will contribute a further 2 protons, from which the 10 from the alpha particles would have been taken. The correct answer is C, Z minus 8, A minus 20. 31, kinetic energy of a mass of an object 4 kg traveling in a straight line increases from 32 to 200 in 3 seconds. What is the value of the resultant force? Okay, so let's just calculate this. I'm going to say a half mv squared is equal to 32. A half times the mass is a half times 4, which is going to be 2. V squared is equal to 32. V squared is going to be 32 over 2, which is 16. V is going to be equal to 4 meters per second. Okay, now after that, we're going to have a half mv squared is going to be equal to 200. So we're going to have a half times the mass, which is just going to be 2. So in other words, 2v squared yet again is equal to 200. V squared is equal to 100. V is equal to 10 meters per second. Okay, cool. So what are we looking for? We're looking for the value of the resultant force. So to work out the value of the resultant force, we need to work out the change of momentum. So F is going to be equal to delta P over delta T. How much has the momentum actually changed? Well, that's just going to be mass times the change of speed. So the mass is going to be 4. The speed has gone from 4 to 10. So that's a change of 6. All of that in a time of t is equal to 3 seconds. What is that going to give me? Well, that's just going to give me 8 newtons. Correct answer is C. 32, in the following circuits, all 5 resistors have exactly the same resistance. Reading on the voltmeter is 1 volt. What is the voltage across the battery? Okay, the first thing to do with this problem is to realize that in this parallel combination, we are going to have 2 volts like this. Let's call this one here R. Well, all of these here are R. Then I'm just going to redraw the circuit just to make it a tiny bit easier. I'm going to combine this one and this one as a series resistor of 2R. I'm going to have just the parallel combination. Now, this parallel combination here will be equivalent to what sort of resistor? Well, that's just going to be 1 over R plus 1 over 2R raised to the negative 1. What is that going to give me? 2 plus 1, which is going to be 3 over 2R flipped, which is the same as 2 over 3 R. Okay, so the let's just fix that a little bit, make sure the R is down here. So what is that going to give me? Well, this one here is going to be 2 over 3R, and this here is going to take 2 volts of the share of the voltage. So if this here is 2 volts, I can use the fact that I can use the ratio of the resistances voltages to figure it out. So I can say that 2 over the value of the resistance, which is equal to 2 over 3R, will be equal to the voltage across this one. I don't know, let's call it Vx, like this, divided by its resistance, which is just 2r. So that means that Vx will be 2 times 2, which is 4. The r's will cancel, over 2 over 3, which is going to be 4 times 3 over 2, which is 12 over 2, which is just going to be 6. Okay, so this one here is just going to be 6 volts. 6 plus 2 is going to be 8 volts. And this here is our final answer. Correct answer is E. 33. Two hovercraft are horizontally in opposite directions along the same straight line. The mass and speed of each hovercraft are shown in the diagram. Horizontal resistive forces acting on each hovercraft are negligible. The hovercraft collide and stick together. Collision lasts for 0.10 seconds. Okay, just before the collision, what is the total kinetic energy and the magnitude of the total momentum? Okay, so let's start off with the magnitude of the total kinetic energy. So probably not an easy way of doing this. Let's just calculate that over here. So total kinetic energy, what is that going to be? That's going to be 1/2 times 1,000. Multiply this by v squared, which is going to be 20 squared, plus 1/2 times by 2,000, like that. Multiply this by 10 squared. This is a little bit tedious. Okay, so 1/2 times 1,000, what is that going to be? 500. Multiply this by 20 squared, which is going to be 400, plus 1/2 times this is going to give me 1,000, plus yet another factor of times by another factor of 100. What is that going to give me? Well, 500 times 400, that's going to 5 times 4 is just going to give me 20. Okay, and then I have 4 more zeros, so it's going to be 200,000 plus 100,000, which together is just going to be equal to 300,000, which is 300 kilojoules. So it's going to be 300. The total kinetic energy, I can get rid of those answers. Total momentum. Well, notice how mass and speed, this one is 1,000, this one here is 20, this one here is 2,000, this one here is 10. So if we multiply the two numbers together, each of them just gives me sort of 20,000 kilograms meters per second. So the total momentum after the collision is going to be 0. So we can get rid of those answers here as well. What is the average force on each hovercraft? Okay, so F is equal to the rate of change of momentum, because total momentum afterwards is 0. That means that they grind to a halt. And this here is, let's pick the 1,000. Initially its speed was 20. Divided by the time of the collision, which is 0.1. So this here is bound to be a pretty big number in newtons. It's definitely not going to be 2,000, because it's 1,000 times 20 multiplied yet again. So yeah, correct answer is F, 200. 34. Graph shows how a car's velocity changes in 85 seconds. What proportion of total distance it traveled constant velocity? Okay, so let's just work out this area. There might be a clever way of doing that. 15 to 75. Okay, what is that? This area here is going to be 60. Multiply this by 16. What is that going to give me? Well, 16, let's go times 8. Multiply this by 2, which is 60 times 8 is 480. Multiplied by 2, which is going to be 960. Okay, so this area is 960. What is the other area? Well, this one here is going to be 16 divided by 2, which is going to be 8 times 10. So this area here is going to be half base times height, which is half of 16, which is 8. Multiply this by 15. 4 times 15 is 60. Multiply this by another 2. Well, this here is just going to give me 120. Okay, now let's add stuff up. So this here is going to be 960 divided by 960 plus 120 plus 80, which is gonna be 960 plus 200, which is 960 over 1160, like that. Let's do a little bit of division. So 960 over 116, what is that going to give me? 48 divided by 2 over 58. 48 over 58, what is that? Is the same as 24 and 29. So correct answer should be D. Question 35. Block is designed with a cylindrical channel. Block is 100 centimeters long, has a square cross-section of side 22 centimeters with a cylindrical hole in the middle. Diameter of the cylindrical hole is 14 centimeters, and density of the material from which the block is made is 0.1 gram per centimeter. What is the mass of the block? We can take pi to be 22 over 7. Once again, we just mentioned density, so we're going to find the equation that m is equal to rho v. Very, very useful. We don't really know what the volume is though, so well, the volume is the bigger volume, take away the volume of the hole. So V is going to be equal to 22 times 22 times 100, which is going to be 22 times 100. 22 squared. Take away pi, multiply this by 7 squared because we're given the diameter, so pi r squared, multiply this by the length, which is 100. Okay, so this here is equal to 22 times 100, take away 22 over 7 times 7 squared times by 100. Okay, so let's take a factor of 22. Let's take a factor of 22 times 100 out, actually. What is that going to leave me? That's going to leave me with 22. Take away just 7, isn't it? Because this 7 here is going to cancel out with this 7, 20 over 100. Yeah, so that's like that. So it's going to give me 22 times 100 multiplied by 15. Well, what is that? I'm just going to leave it as this times 15 for now, and let's calculate the actual mass. So the mass is going to be 0.1 multiplied by 2,200, multiply this by 15. Because we have density in grams per cubic centimeter and we have the volume in cubic centimeters, this is going to give us the answer in grams. Okay, so this here is going to give me 0.1, 22 times 15, what is that, 33, 330. Okay, how many more zeros do we have? We have 2 more zeros left over. Multiply this by 0.1, this is going to give us 3,300 grams, which is 3.3 kilograms. Correct answer is B. 36. A sample initially contains equal numbers of atoms of a radioactive isotope X and a stable isotope Y. Y has a half-life of 3 years. Decays in a single step to the stable isotope Y. What is the ratio of the number of atoms of X, number of atoms of Y in the sample 6 years later? So 6 years later, in this case, is 2 half-lives. I'm just going to do a table this time. So let's say that we have X and let's say that we have Y. And after sort of 2 T half-lives, X, let's say that initially we had N. What's going to be left of X is N over 4. What's going to happen to Y is initially we had N, but then we're going to gain 3/4 of N. So, okay, what are we looking for? We're looking for the number of atoms of X, which is N over 4, divided by the number of atoms of Y, which is going to be N plus 3 over 4N. What is that? 4N over 4 plus 3 over 4N. That is 7 over 4N, like so. So 7N over 4. Let's cancel the N. Oh, in the fourth, 1 over 7, correct answer is B. Okay, let's do the 2020 paper. Starting off with question 1. We have a soldering iron, has a copper tip of mass 2 grams. The tip is heated with 30 watts of power. In 50 seconds, the temperature of the tip increases by 200 degrees C. How much energy is transferred from the tip to the surroundings? Okay, so probably the first thing that we want to do is calculate the thermal energy which is just going to be given by mc delta theta. So the mass is 2 grams. This here is in joules, so I'm just going to be careful with the units. I'm going to go 2 times 10 to the power of minus 3, multiply this by 400. The change of temperature is just going to be 200. Okay, so what is that going to give us? 2 times 400 is 800, divided by 1000 is going to give us 0.8, multiply this by 200, this here is going to be 160. Now let's just compare this with the overall power, the overall energy, which is just power times time. And let's take away this number of 160. Power times time is going to be 30 times 50, take away 160, which is 1500, take away 160, which is 1340 joules. Correct answer is C. 22. The diagram represents the structure of a charged atom ion of one isotope of an element. Which diagram represents the structure of an oppositely charged ion of a different isotope of the same element? Okay, so for this one here, we have 4 electrons, and we have to decide whether these ones are the electrons or these gray ones are the protons. I mean, which ones are the protons, which ones are the neutrons, not the electrons. Okay, because it's an ion, that means that those ones here need to be the protons. So we have 4 electrons and 3 protons. In order to have the same element, we'll need to have the same number of protons, but we will need to have 2 less electrons. So it's not just neutral with 3, but we need to have 2 electrons. And look at this, option B fits the bill perfectly. 23. A sample of an ideal gas is sealed in a cylindrical container by a piston as shown in the diagram. The particles of the gas are moving with an average speed v and collide with the surface of the piston with a frequency f. The piston is now slowly pushed into the cylinder until the gas occupies half of its original volume, but the gas remains at the same temperature. What is the new average speed of the particles? Well, because they're at the same temperature, even though this formula is not necessarily on the spec, but a half m sort of c RMS, the root mean square speed is directly proportional to the temperature in Kelvin. So if we're at the same, where everything else is a constant, if the temperature is constant, then the average speed of the particles will be the same, the RMS speed. So we can get rid of the average speed because the temperature increasing, because the average speed will still be the same. So what about the frequency? Well, the frequency should increase because the particles are going to need to travel less between collisions. And if they travel less between collisions, the rate of collisions will increase. The only answer in which the rate of collisions increases is F. 24. This is a tricky one. A water wave is traveling in a shallow tank of water. The wave passes from region X into region Y, where the speed of the wave differs from that in region X. The diagram shows the direction of travel in the 2 regions. Okay, in region X, the angle between, basically we're given that this angle is theta, and we're given that this angle is 5. What is the angle of incidence and the angle of refraction, and in which region the speed of the wave is greater? Okay, so let's do this bit first because it's a little bit easier. So the speed of the wave will be greater in X. Why is that? You can kind of see that the refractive index is bigger here, and you can just remember that light slows down in something like water if it's coming from air. If you wanted to prove this mathematically, you can see that the wavelength in this region is decreasing, and if the wavelength is decreasing, the frequency remains constant. So if this thing decreases, v must also decrease. So we can get rid of all the answers that mention that y is the one with the greatest speed. Okay, so the first thing I'm going to do is draw my normal. So let's start off with my normal here. And then I'm also going to draw this horizontal line across here. Okay, so if this angle here is theta, that means that this angle here will also be theta. So if that's the case, This angle here is 90, but this tiny angle here is going to be 90 minus theta, which means that the angle here will just be theta as well. So this here is actually our angle of incidence. Very similarly, let's have a look at the question below. So what I'm going to do is draw my lines of direction, or draw my actual ray. Let's draw this a little bit bigger this time. And I'm going to take just this one here to also be equal to phi. Now, shall we take a slightly different triangle? So I'm going to take the normal, which is going to be somewhere along here as well. I'm going to consider this angle here to be 90, which is going to make in this triangle right over here, hopefully you can see, this one here will be 90 minus phi. But then this whole thing here is equal to 90 degrees, which means that this angle here to the actual sort of 90-degree line, which is the normal, will be just phi. So this here is a kind of a tricky problem, but the correct answer is A, angle of incidence is theta, angle of refraction is phi. 25. Uranium-238 decays by a series of alpha and beta minus emissions to become the stable isotope lead-206. How many beta minus particles are emitted in the decay of one uranium-238 nucleus to lead-206? Okay, so the way we do these questions is, first of all, we start with how many alpha particles are emitted. So remember, an alpha particle is a 4 and a 2. Then we look at the atomic mass number. So this here has changed from 238 to 206. So that means that there is a difference in the atomic mass number of 32. So that means that we need to have, well, 8 alpha particles have been actually emitted. Okay, now what effect would 8 alpha particles would have had on the proton number? Well, the proton number would have changed by 16. Why is that? Because 8 times 2 is 16. But we can see that in reality, the proton number has changed from 92 to 82, which is 10. So that means that 6 neutrons would have turned into protons, meaning that there's a difference in the proton number of now 10, i.e. correct answer is 6. 26. In a lab, liquid nitrogen is stored at a very low temperature in the vessel shown in the diagram. The vessel has a double wall made from a poor thermal conductor. There's a vacuum gap between the two walls. The inner surface of the inner wall is shiny. The outer surface of the outer wall is shiny. Which of the following statements explain why these features help to isolate the liquid nitrogen? Okay, the shiny inner surface of the inner wall is a good emitter. So shiny surfaces are good reflectors, not emitters. So this one is wrong. Thermal radiation cannot travel in a vacuum. That is definitely not correct. Shiny outer surface of the outer wall is a poor absorber of radiation. This one here is fine. So correct answer is D, 3 only. 27. The primary coil of an ideal 100% efficient transformer is connected to a 240 volts mains supply. The lamp is connected to a secondary coil, has a voltage of 12 volts across it. An identical lamp and switch are also connected as shown. When the switch is open, the current in the primary coil is 0.10 amps. The switch is now closed. What is the current in the primary now? What is the current in lamp L? Okay, so let's just first consider this with the actual switch open. What I'm going to do is I'm just going to use that VP over VS is equal to IS, so they flip for the actual current over IP. Okay, so we know that the current in the primary coil is 0.1. What is the current in the secondary coil going to be? Well, IS will be VP over VS, multiply this by IP. So what is that? 240 divided by 12, multiply this by 0.1. Okay, so this here is just 20 times 0.1, which is just going to give me 2.0 amps. Okay, now what's going to happen when the switch is closed? So when you close the switch in exactly like a regular circuit, and now let's actually close this switch, what's going to happen? Well, what we're going to have is very, very similar situation, and we're going to have 2 amps across here, but then we'll also have 2 amps across here. Well, why is that? The resistance of the circuit would have actually dropped the overall resistance, but across here, assuming that the filament lamps still have the same resistance, the current through them is going to be equal to the potential difference, which is still going to be the same because that's just to do with the ratio of the coils. And if both of the filament lamps are identical, their resistance is the same, then I is going to be equal to V over R. So it's going to be the same current running through this one as well, which is going to be 2 amps. So overall, we're going to have 4 amps here. Now they're asking us for the current in lamp L. Well, we know that this here is going to be 2, so we can get rid of pretty much all the other answers, and then we're going to be just between 2 answers. What is the current in the primary coil going to be? Is it going to be 0.1 or is it going to be 0.2? Well, if the voltage here is remained the same at 240 and here it's still the same at 12, in order to get higher or double the current here, we should probably have double the current over here. So that here would have changed from 0.1 all the way up to 0.2. Correct answer is E. 28. A DC electricity transmission system uses an undersea cable to send electricity from one country to another. On a particular day, the first country supplies electricity at a voltage of 400 kilovolts and 2000 amps to the transmission system. The second country receives electricity from the transmission system at 160 at 4000. What is the percentage efficiency of the system and how much energy is wasted every minute? Okay, so I'm just going to call one of the powers P1 and I'm just going to calculate it. So this here is just going to be IV. So what is that going to be? 400 times by 10 to the power of 3. Multiply this by 2000 amp. I'm going to write this as 2 times 10 to the power of 3. So 400 times 2 is 800 million times 10 to the power of 6 watts. P2 will be 160, multiply this by 10 to the power of 3, multiply this by 4 times 10 to the power of 3, which is going to give me 160 times 4 is 640 times by 10 to the power of 6. So, okay, what will the efficiency actually be? We can pretty much immediately see that it's not going to be 20%. It's way more than half. It's going to be 80%. And if you wanted to, you could actually calculate this. The way you would do that is just do 640 over 800, multiply this by 100. This here is 80%. Almost be 80%. Okay, now what is the how much energy is wasted every minute? So in order to work out the energy has been wasted, okay, let's just do power multiplied by time, or delta P, let's call it. This here is the change of power. So 800 take away 640 is 160 times by 10 to the power of 6. And then I'm going to multiply this by another factor of 60. Okay, so what is that going to give me? Well, that's going to give me 1.6 times 10 to the power of 8. Multiply this by 60. Notice how the answers here all have different powers, except for this one. So let's see if we can narrow it down to a power. 1.6, 10 to the 8, multiplied by 60, which is another factor of 10. So this here means that the answer should be of the order of 10 to the 9. Correct answer should be D. Also, 1.6 multiply this by 6 is going to give us like 9.6 times something, so it has to be correct. 29. A circuit contains a 12-volt battery, a thermistor, and a fixed resistor connected in series. The graph shows how the resistance of the thermistor varies with temperature. Okay, so what I tend to do with those is just to draw a really simple graph. So here's my thermistor like this, and here's another fixed resistor. What do we know? It's a 12-volt battery. Okay, the graph shows when the temperature of the thermistor is 10 degrees, the current of the circuit is 25. Okay, so 10 degrees is over here. That means that the resistance is going to be 400 ohms. Current of the circuit is 25 milliamps. Okay, so one of the things that we could probably do is just calculate some voltages. Voltage across the thermistor, that's just going to be IR, which is going to be 400, multiply this by 25 milliamps, which is times 10 to the power of minus 3. Okay, so 400 times 25, that's just going to give me 10,000, 1, 2, 3. And then I have another factor of 10 to the power of minus 3, which should just give me 10 volts. Okay, so if I have 10 volts across this one, I'm going to have 2 volts across the other one. Can I calculate its resistance, the value of the fixed resistor? Yes, I can, because I can just use that R is equal to 2, which is the voltage, divided by the current, which is going to be the same because we're in a series circuit. So it's going to be 25 times 10 to the power of minus 3. Okay, so 2 over 25, 1 over, let's say 1 over 25 is going to give me 0.04. So 2 over 25 is going to give me like 0.08. And then I have the factor of... So 2 over 25 is going to be 0.08, and then we need to multiply by 10 to the 3 from the bottom of the fraction, which is just going to give me 80 ohms. Okay, so this circuit here is essentially like a series circuit, with this here being 80, and then this thing here you can vary the resistance of. Okay, so what is the current when the temperature of the thermistor is 80 degrees? When it's 80, that means that the resistance is just going to be 40 degrees, 40 ohms. Okay, so the current is just going to be equal to the total voltage, which is 12, divided by the total resistance, which is going to be 40 plus 80, which is 120. That means that the answer should be, what is that, 0.1 amps, which is 100 milliamps. Correct answer is C. Question 32. Fixed horizontal metal rails are side by side and 12 centimeters apart. The rails are connected to a DC power supply to a switch that is initially open. A freely movable metal rod of length 20 centimeters is placed on the rails as shown in the diagram. The angle between the rod and the rails is 90 degrees. However, is placed a magnetic field of magnitude 0.5 T that is directed perpendicularly into the page. This whole problem is going to boil down to F is equal to Bill. Let's work out the magnetic force that is present on the movable rod. Why would there be a magnetic force? Because the whole thing is in a magnetic field which is into the page, and there's going to be a current which is going to be going from positive to negative. Okay, so F is equal to build, which is going to be 0.5 multiplied by the current, which is 2.4 amps. Now the length of the metal bar inside of the actual conductor is the only thing that inside of where current actually flows is the only length that we need to take into consideration. So I'm going to multiply this by 12 centimeters, and I'm going to write this as 0.12. Okay, so what is that going to give me? That's going to give me 1.2, multiply this by 0.12, which is going to give me 0.144 newtons. Okay, so I've got the direction of the magnetic force. Now, assuming the whole thing is kind of like laid out horizontally, I can just directly set that equal to ma, meaning that I can find the initial acceleration using just F over m. Am I given the mass? Well, sort of. I'm given the weight, so I need to divide by another factor of 10. So it's going to be 0.144 divided by the mass, which is going to be 0.04. What is that going to be? Well, 0.04 multiplied by 3 is going to give me like 0.12, so it's going to be just over that, which means that it's going to be around 3.6 looking at the answers. Okay, so all we need to do is decide which way is the force going to be. Left hand rule, so we just use FBI. So if we were to apply this, we can see that the direction will be to the right, so meaning that the correct answer is F. 31 visible light waves are EM waves that travel through a vacuum at 300,000 kilometers per second with wavelengths that range from 400 nanometers to 750 nanometers. Okay, the EM waves emitted by the source are all frequencies 6 times 10 to the 12 and 6 times 10 to the power 14 hertz. Which statement about the emitted by the source is correct? Infrared waves are emitted but not ultraviolet or visible light waves. Okay, so we just need to convert the frequencies to so all we need to do is convert those frequencies to wavelengths and then compare them with the spectrum. Okay, starting off with this one. So we have 3 times 10 to the power of 8 divided by the frequency, which is going to be 6.0 times by 10 to the power of 12. What is that going to give me? That's going to give me 3 over 6 multiplied by 10 to the 8 over 10 to the power of 2, which is going to be a factor of 5. And then what we have left is 10 to the power of minus 5. Or we can think of it as sort of 0.5 times 10 to the power of minus 4, which will end up giving me 5 times 10 to the power of minus 5 meters. This here is just below visible light, so it's going to be in the infrared. So we know there's going to be infrared that's being emitted. Okay, then let's also do 3.0 times 10 to the power of 8, divide that by 6.0 times by 10 to the power of 14. Okay, so similarly, this here is going to give me 1 over 2, which is 0.5. And then let's just leave it in standard form. It's going to be 5 times 10 to the power of minus 7 now. Okay, this is definitely visible. It's roughly the color yellow, I think. Correct me if I'm wrong. So we're going to have infrared and visible. So the first answer, infrared but not ultraviolet or visible, this is wrong. Infrared and visible light waves are emitted but not ultraviolet waves. Yeah, that has to be the correct answer. Ultraviolet waves have even higher frequency, even smaller wavelength. Okay, question 32. 2 trolleys are moving towards each other at a stationary horizontal track. One trolley has a mass of 8 kg and is traveling to the right at 4 meters per second. The other trolley has mass 2 kg and is traveling to the left at 1 meters per second. When the trolleys collide, they stick together. How much kinetic energy is transferred to other forms? Okay, so what we need to do is use conservation of momentum. So I'm going to do mass times velocity before they stick together. So that's going to be 8 times 4. The other one is moving the opposite way. So I'm going to minus 2 times 1, which is just 2. And that's going to be equal to the total mass, which is 8 plus 2, which is 10, multiplied by the some common speed v afterwards. Okay, that works quite nicely because we have 32 minus 2, which is just 30, which is equal to 10v. That means that v will be 3 meters per second. Okay, so if I know the v, I can probably, let's work out the final kinetic energy. So kinetic energy final is going to be a half the mass which is going to be 10 multiplied by 3 squared, which is 9, which is going to be 45 joules. Now let's work out the total kinetic energy beforehand. So the kinetic energy of just this object will be 1/2 times 8 times 4 squared, which is 4 cubed, which is 64 joules. The other one here, well, that's just going to be 1/2 times 2 multiplied by 1 squared, which is just 1, so that's just going to be 1 joule. So the total kinetic energy before is going to be 64 plus 1, which is 65. Take away 45, that's just going to give me 20. Correct answer is, well, C. 33, a car of mass 800 kilograms travels in a straight line along a horizontal road. The car accelerates non-uniformly from rest for 5 seconds, then moves at a constant speed as shown in the distance time graph. What is the average resulting force on the car from the time for which it is actually accelerating? Okay, so F is going to be equal to delta P over delta T. Anytime I see average force, I kind of know that I'm going to be using this equation. So, okay, what is the final speed? Well, what speed does the car reach here? We can see that after that, we have a region at constant velocity. Because this is a dt graph, I can just work out the gradient on this portion. So the gradient here is just going to be 30 over 5, which means that my final speed v is going to be 6 meters per second. So now I can just work out the car starting from rest, isn't it? Cursor is from rest. Yeah, perfect. So that means that I'm just going to have essentially mv over delta t, which is going to be 800 multiplied by 6, divide that by 5. 800 over 5 is 160 multiplied by 6, 960. Correct answer is D. 34. Cubes of size 2 centimeters are tightly packed in a rectangular box with internal dimensions 12 by 10 by 6. Each cube is either solid concrete or solid steel. There's twice as many steel cubes as concrete ones. What is the total mass of the cubes in the box? This here is potentially a time-consuming question. One of the things that we probably want to do is use the fact that there's twice as many steel cubes as there are concrete cubes. Okay, so what is the total volume? Well, the total volume is going to be 120 times 6, or 12 times 10 times 6. 120 times 6, what is that? 720 cubic centimeters. Okay, so let's just divide it by the volume of one of the cubes. So I'm going to do 720, divide that by 2 to the power 3, which is going to be 720, divide that by 8. So this here will be 90 cubes. Okay, there are twice as many steel cubes as concrete cubes. You can probably immediately see that that means that there's going to be 60 steel cubes and there's going to be 30 concrete ones. Okay, what is the total mass? So every time we see this, I guarantee you're going to have to use the fact that mass is equal to density times volume. So I'm going to say that the total mass is equal to the mass of the steel cubes plus the mass, the total mass of the concrete ones. Okay, so the mass of the steel cubes, well, there's 60 of them, and I'm going to need to multiply by the density, which is going to be 8. I'm going to need to multiply by their volume, which is 8 as well, plus 30 times the density of the concrete ones, which is 2, times by their volume, which is still the same, which is 2 by 2 by 2, which is 8. Quick check of units, because we're working in centimeters, grams per cubic centimeters. We're good with the units. Okay, so this here will be 6 times 8 is 480 multiplied by 8 plus by 60 times 80, which is going to be 480 as well. What is that going to be? 480 multiply this by 8. This here is going to be, okay, 400 times 8 is 3,200 plus 80 times 8. That's going to be 3840 plus 480, which is going to be, quite a bit over 4,000, but not answer F. So the correct answer should be E, 4320 grams. 35. This here is a bit of a confusing question. I'll show you the way I think about it. If you think about this a different way, please let me know in the comments. I'll be very interesting to see your approach to this problem. So P and Q are two fixed points on the surface of the ocean, which are 6 meters apart. An ocean wave travels in direction P to Q. The wave has a frequency of 0.5 Hz and travels at a constant speed. A wave peak passes Q at a time t is equal to 0. The next wave peak traveling towards Q passes P at a time t is equal to 0.8. What is the speed of the wave? So the way I think about this is, because in this case we've got an ocean wave which is traveling from P to Q. We have a traveling wave, which is almost like having like a traveling boat. Almost think about this. What if everything was stationary? Because if everything was stationary, the time between peaks is going to be 1 over the frequency, which is going to be 1 over 0.5, which is going to be 2 seconds, right? So if it's 2 seconds to be expected between peaks, but we have 0.8 seconds between peaks. So that means that there's going to be some sort of a difference in timing, which is going to be 2 minus 0.8, which is going to be 1.2 seconds. Now we can calculate the speed that corresponds to this time difference just using distance over time. We're given the distance here, which is going to be 6 over 1.2, which just gives me 5 meters per second, which is the correct answer. If you think about this problem differently, do let me know. I'll be very curious. 36. A sample contains only one radioactive isotope. The isotope decays in a single step with a half-life of 120 minutes to a stable isotope. Okay, the sample is placed near to a radiation detector, which measures the count rate. The count rate reading is 910 counts per minute. After 240 minutes, the measurement is repeated. Count rate is now 238. After a further 360 minutes have elapsed, the third measurement of the count rate is made. What is the count rate due to the background radiation? What is the expected reading in the third measurement? Okay, so the thing is that the background rate, let's assume that to be absolutely constant. In the first case, we have some sort of reading x plus the background is going to be 910. Now, in the second reading, we're going to have this reading x, but that's divided. What's happened to x during that time? Well, it's halved twice. Why has it halved twice? Because the half-life is 120 minutes, and this is 240, which is 2 half-lives. So we're going to have x over 4. Plus that same background reading is going to be 238. So then what I can do is I can just say that x is going to be 910 minus b. And here I can say that x is going to be 4238 take away b. I can set those two equal to one another, see what you get. 910 minus b is equal to 4 times 238. Take away 4b, so what is that going to give me? 910 minus b is equal to 800 plus 4 times 38, which is 952. Take away 4b minus b, which is going to be what? 3b is equal to 952. Take away 910. 3b is equal to 42. b is equal to 14. Okay, the problem is not even done yet. So we've got the background, which is 14, so we can get rid of all of these. So what's happened to the third measurement? There is something very, very sneaky about this problem, and that is that after a further 360 minutes. So if the count rate was initially 238 on the reading before, take away the background, and we're going to get that the reading will, not the reading, but the actual amount of decayed particles measured would have been 238, take away 14, which is 224. Okay, so now let's do 224 after a further 360 minutes. That means that we're going to halve 3 times, so divided by 2 to the power of 3, which is 224, divide that by 8, and this here is going to give me 28. But even sneakier, because it's 28, but then we need to, it's asking us for the third measurement, we need to add in a further, you need to add in again the background radiation, so that means the correct answer for 36 should be H, 14 and 42. 37. A solid uniform sphere is made of metal of density rho s, has a radius r and a volume v. It falls vertically through a viscous fluid of density rho l. 3 forces act on it: its weight, a drag force d, and an upthrust u. The magnitude of the upthrust force is equal to the weight of the liquid displaced by the sphere. Magnitude of the drag force is given by this. What is the terminal speed? Okay, so the way I think about this is we have mg, which is acting, and then upwards we have some drag, and we also have some upthrust as well. Together they're equal. So we know that mg is going to be drag plus the upthrust. Okay, so the mass is going to be equal to the density multiplied by the volume, where this m here is the density of the steel. Multiply this by g. Okay, so then we're going to have the drag, which is equal to krv, plus the upthrust. So the upthrust is equal to the weight of the liquid or fluid that's been displaced. So here we're going to have the density multiplied by its volume multiplied by g. If you're curious, this here is equal to m liquid multiplied by g. That's just the weight of it. So this here, ml, is just equal to rho l times v, because mass is equal to density times volume. So this is where this expression actually arises from. Okay, so we're looking for V, so I'm just going to rearrange for KRV, which is going to be rho SVG, take away rho LVG. V is going to be equal to, take VG outside, rho S, take away rho L, divide that by KR. Hopefully that corresponds to an answer. Seems like it's answer G. Okay, question 38 and 39. A parachutist of mass 80 kg drops from a plane traveling at 40 meters per second, 2,000 meters above the Earth's surface. How much work is done by a parachutist drag forces during the fall? Okay, so anytime we're looking for resistant forces or anything like that, typically we tend to do that, we tend to use that change of work done is equal to change of energy, which is also equal to force times distance, where this here will be the resistive force. In this case, we're just looking for the work done, so we don't have to worry about this. All we need to do is work out the change of energy. Now, the change of energy will be equal to the energy at the, the top in the plane, take away the energy at the bottom. Okay, so what is that going to be? That's going to be at the top. Now, the difference is that we have some kinetic energy as well, because the plane is also traveling. So we're going to have a half m, let's call it v1 squared plus mgh, take away the speed of the bottom, which is going to be a half mv squared. Okay, a half m is just going to be a half times 80, which is going to be 40, multiply this by 40 squared, plus m, which is going to be 80 times 10, which is going to be 800, multiplied by the height, which is going to be 2,000. Okay, and then we're going to take away a half mv squared. That's going to be pretty much negligible, isn't it? Because it's going to be a half, which is going to be 40 times by 25. Okay, we could probably even get away with getting rid of this and just calculating the first bit. So 40 times 40 squared is going to be 40 to the power of 3, which is going to be 64. And then 1,000 plus 800 times 2,000. 8 times 2 is 16. Then how many zeros do we have? Multiply this by 10 to the power of 5. Take away like 1,000, which is basically going to be negligible. So is going to be pretty close to, well, it's going to be one of these. Now, the question is, which one of these is it going to be? Well, it's going to be 16 plus the next digit is 6, 4. So the next digit should be 6, because then we'll just get rid of this 1,000. So correct answer must be D. Those little tricks of not fully calculating something are just really, really important with the ESAT. Okay, 39, we've got a light spring of unstretched length 0.10 meters, has a spring constant of 20 newtons per meter. The spring is suspended so that it's vertical, and a load of mass 0.05 kg is attached to the end of the spring. The load is pulled vertically downwards until the length of the spring is 0.3 meters. The load is then released. What is the speed of the load at the instant the spring returns to its unstretched length? Okay, so the first thing you probably want to do is work out the potential energy of the spring, which is just going to be a half kx squared. And now it's time to be careful, because we're going to have a half times k, which is going to be 20. Now, how much is the extension? Well, the unstretched length is 0.1, then goes to 0.3, so the extension is actually going to be 0.2, and then we're going to square that. So this here will be equal to 10, multiply this by 0.2 squared, which is going to be 10 times, I don't know, 2 over 10, all of this squared, which will end up being 4 over 1, 4 over 10, which is going to be 2 over 5, which is going to be 0.4 joules. Okay, so this here is kind of like our input energy. Now, this energy of 0.4 will end up going to partially potential energy, mgh, because it's going to go back up again by another 0.2, and then to kinetic energy, which is going to tell us how fast it's actually going to be moving. Okay, so 0.4 will be equal to its mass, mgh. So what is the mass? 0.05. Multiplied by g, which is 10, so we can just write this as 0.5. Multiplied by the height, so it's gone back up another 0.2, plus a half m. Okay, a half times 0.05 times v squared. Okay, so 0.5, multiply this by 0.2. This here is going to be equal to 0.1. So that's going to give me 0.4, take away 0.1, which is going to be 0.3, is going to be equal to a half times 0. Like this, basically 0.0. 1 extra 0, so 0.05 v squared. Let's bring this up here, and then we'll end up with 0.6 over 0.05, which is equal to v squared, 0.6, which is 6 over 10, okay, and then that's divided by 0.05, which is going to be 5 over 100, okay, so 60 over 5 is just 12, okay, so this here will just be 12 is equal to v squared. V is going to be root 12, meaning the correct answer should be G. Okay, last one. A rocket is traveling in space, is burning its fuel at a constant rate. By expelling fuel, the burned fuel for a nozzle, the engine is applying constant force for the rocket. What is happening to the magnitude of the acceleration of the rocket? I actually know the answer pretty much from the top of my head. It is increasing at an increasing rate. How can you prove this? A couple of different ways. I suppose you can maybe use this. Technically, you probably have to use something known as the Tchaikovsky rocket equation. That's a whole different story. A is equal to F over m. So then you could probably, the mass ends up decreasing at a linear rate, like this. There's actually an Olympia problem that I've done on this ages ago, which is a lot of fun. But this function ends up increasing faster as m gets smaller. So it's increasing at an ever increasing rate. Correct answer is A. Okay, paper 2021. A resistor has a constant voltage of 9 volts across it. Total charge passes through the resistor in 4 minutes. We're looking for the power dissipated. So power is equal to IV. I is just equal to Q of T multiplied by V. The charge is 180 over a time of 4 minutes. 4 times 60. Multiply this by 9. You can do some cancellations. And what are you going to get? 3/4 of 9, which, looking at the answers, the only one is that can be the answer is 6.75. Notice how I didn't actually finish the calculation, but I realized that the answer should be just a little bit below 9, meaning that I've narrowed it down to 6.75 watts. Okay, air is trapped in a cylinder by a piston. Density of the air is rho. Piston is moved, so the pressure increases by 20%. So if the pressure increases by 20%, PV is equal to a constant. That means that P must increase by 20%, which is kind of like 1.2. 1.2 is equal to 6 over 5. So as a fraction, it increases by 6 over 5. What should happen to the volume? Well, the volume should, decrease. So essentially the volume, let's call it V2, is 5 over 6 V1. Now, what is the new density? Density is inversely proportional to this. So if the volume has kind of gone down, the density should have increased by that same factor, which is 6 over 5, meaning that the correct answer has got to be E, 1.2 times the original density. A non-ideal transformer has 100 turns on the primary coil and 25 turns on the secondary coil, provided with 3 kilowatts of power at a current of 12.5 amps. Voltage output is the same as an ideal transformer, seems important, and the current in the output coil is 40 amps. What is the efficiency? Okay, so the efficiency is equal to the power output, which is the secondary power divided by the primary power, multiply this by 100. Well, let's see. We know what the primary power is. That's just 3,000. The secondary power, we need the voltage and the current to figure it out. So let's just use Vs over Vp is equal to Np over the other way. So I wrote this. We should write this as Ns over Np. Okay, so what are we looking for? We're looking for Vs, which is Ns over Np, multiply this by Vp. So this here will be 25 over 100, which is a quarter. Multiply this by Vp. Hopefully we're given this. Are we given Vp somewhere? We can probably figure it out. Oh yeah, because we have 3,000 kilowatts at 12.5 amps. So this here will be 3,000 divided by 12.5. This here is going to be 3 times 1,000 over 12.5. So 1,000 over 12.5 is just 80. So 3 times 80, that's just 240 volts. Okay, so this here is a quarter of 240, which of course is just equal to 60 volts. Okay, so I think we're in business. The secondary power is just going to be 60, and we're given the current here, which is just 40 amps, and then we just need to divide that by 3,000, multiply this by 100 to get the percentage. Let's do a bit of sort of cancelling things out. 6 over 300, what is that going to give me? 50. So this is going to give me 4 over 5 multiplied by 100. Correct answer is 80%. 24, car of mass 1,400 kg, stolen caravan of mass 1,000 kg along a straight horizontal section. Driving force from the engine is increased by 3,000, causing the car and the caravan to accelerate. At one moment during the acceleration, the resistive force on the car is increased by 200 newtons, and the resistive force on the caravan has increased by 400 newtons. What is the acceleration of the car and the caravan at this moment? So before that, they were balanced. The resistive forces were 0. So we're just going to consider the excess forces. the driving force is going to act on the whole sort of system, which is going to be 1,400 plus, was it 1,000 kg. So we're going to apply that the net force is equal to mass times acceleration. So it's going to be 2,400 total mass that shares the same acceleration, because otherwise they're not going to be connected very well. So what is the new net force? Well, that's just going to be the differences between the increase of the driving force, take away the increase of the resistive force, which is just going to be 600. Sorry, I've not left a lot of space over here. Let's just write it out properly. So this here will be 3,000 take away 600. In other words, we have 2,400 is equal to 2,400. Correct answer is A. 25. A star is moving away from a space telescope. Okay. Star emits frequency f, lambda c, light travels towards, etc., etc. Frequency of the wavelength and the speed of light measured in telescopes are ft, lambda t, and ct. How did the measured ones compare with the emitted ones? Okay, so if it's moving away, the wavelength is increasing. So that is the whole idea of the redshift. If the wavelength is increasing, that means that the frequency is decreasing, and the speed of light is the same in all frames of reference. So therefore, correct answer is G. 26. Q is an element with several isotopes. Nuclide 3x-7 contains 6 more neutrons than nuclide, etc. We're given another isotope. How many neutrons does this thing contain? Okay, so let's just focus on the fundamentals. We know that this one here contains 6 more neutrons than the nuclide. But they have, notice how they have the same x. So that means they have the same number of protons. So that means that this number 3x minus 7 has to be 2x plus 3, add another 6. So we can say that 3x take away 7 is equal to 2x plus 3 plus 6. 3x minus 2x is just x. Take away 7 is going to be equal to 9. X will be equal to 16. Okay, so we know what x is. Let's consider q. What are we going to have at the top? 3x is 48 plus 1. That's going to be 49. And here we have 16. So what is the question asking us? This here is a proton number. It's asking us how many neutrons does it have. It's going to be 49. Take away 16. Correct answer is 33F. Question 27. A light spring has uncompressed length of 0.10 meters. When an object of mass 0.5 kg rests in equilibrium on top of the spring, the length of the spring reduces to 0.08 as shown. What is the energy stored in the spring due to the compression? So for this one, it's easier to use. E is equal to a half F multiplied by X, where F is just mg. So it's going to be 0.5 times 10, so call it 5. What is X going to be? So we're going from 0.10 to 0.08, so that the compression is going to be 0.02, which is the same as 2 over 100. So what is that going to give me? 5 over 100. Correct answer is C, 0.05 joules. 28. A set of decorative lights consists of 20 lamps connected in series to a DC supply of constant voltage. Total power transferred by the lamps is P. The set is designed that if one of the lamps fails, the lamp becomes short-circuited and then has 0 resistance. The remaining lamps are still lit. If this happens with the set connected to the same supply, what is the new total power transferred by the remaining 19 lamps? Okay, so the first thing that we can probably do is eliminate some of the answers. So the power should increase. Why is that? Because P is equal to V squared over R. Voltage is constant. The total resistance would have decreased, so the power must increase. So we can get rid of these. We can also use this equation to our advantage because V squared is equal to a constant. And that, of course, means that P multiplied by the initial resistance. Let's call it P1R1 is going to be equal to P2R2, so you guys can see what I mean. P multiplied by the initial resistance, which is 20R, is going to be equal to the new power. Let's call it P2 multiplied by the resistance then, which is going to be 19R. So P2, let's get rid of the R's, it's just going to be P multiplied by 20 over 19. Correct answer is D. 29. A train accelerates from rest along a straight horizontal section of track. Force exerted on the train due to its motion is constant. There's a constant friction force. The graph shows how the momentum of the train changes with time. What is the force exerted on the train due to its motors? Okay, so these problems are always solved using F net is equal to the driving force from the motors. Take away the frictional force. Let's call it Fd for the drag. The net force by itself is equal to delta P over delta T, and we can find that using the graph. So delta P over delta T is just going to be 12 over 4. So 12 over 4 is just going to be 3 times 10 to the power of 6 is going to be equal to Fm, take away the drag force, which is 1.8 times by 10 to the power of 7. So Fm is going to be 1.8 times 10 to the power of 7 plus 3 times 10 to the power of 6. So this is only going to change this decimal. Correct answer is E, 2.1 times 10 to the power of 7. Well, it changes this decimal as well, but you know what I mean, same power. Okay, so question 30. A ship travels into a wave that is traveling in the opposite direction of the ship. The ship has a horizontal speed of 8. Speed of the wave is 3. Front of the ship rises and falls with a time period of 8 seconds. What is the new wavelength of the wave? Okay, so the thing to note with these problems is that you, first of all, really want to find the real sort of speed, because the wavelength is still going to be the same sort of physical distance between crests, but it's just going to be covered over a new time. So the effective speed is going to be 8 plus 3, which is going to be 11 meters per second. Why is it 11? Because they're traveling in opposite directions, so the effective speed gets increased. Then we're just going to use that speed is equal to the distance over time, which essentially is the wavelength of the time period. So we can say that 11 is equal to lambda over t. Now the problem becomes easier. Lambda will be 11 multiplied by the time between successive crests, which is 8, giving us 88 meters. No problem with the units. Meters, seconds. Yeah, h 88 meters. Question 31. A 6-volt battery is connected to an 8-ohm resistor and a filament lamp as shown in the circuit. The reading on the ammeter is 0.25 amps. Which graph is a possible VI graph for the filament lamp? Okay, so let's see what we know. We've got a 6-volt battery, and then the reading on the ammeter is 0.25. If it's 0.25 amps, then we know the voltage across this one, which is going to be 8 times that. So 4 times 0.25 is going to give us a volt, so 2 times that is going to give us 2 volts. Okay, so if it's 2 volts across here, we're going to have 4 volts across the filament lamp. So that means that we have a data point, which means that when the current is 0.25, the voltage across the filament lamp must be 4. So it's not going to be this one. It's also not going to be this one. It's not going to be this one. Could be this one. It's not going to be this one. Now, which way does the curve go? The filament lamp's resistance will end up increasing with temperature. So that means that it's going to start curving towards the voltage axis. So because of that, the correct answer is B. 32. A uniform horizontal magnetic field has a magnetic field strength 0.6 Tesla in direction west to east. Okay, so here is the direction, west to east. The horizontal Y is placed in a north-south direction. Okay, so along here, so it's at 90 degrees to the magnetic field. The wire carries a constant current. The wire has a length of 0.4 meters and mass 0.018. Resultant force acting on the wire vertically is 0. Now, for this question, I believe that vertically means in and out of the page, essentially. So if the resultant force is 0, that means that the wire is pushed, well, out of the page. Why is that? Because gravity is acting into the page. Okay, so the first thing that we want to do is actually calculate the magnitude of the force. So for that, or the magnitude of the current, sorry. So we're just going to use F is equal to Bill. In other words, I is equal to F over BL. Okay, so mg is going to be 0.018 multiplied by 10. So this here is going to give us 0.18 divided by 0.6 multiplied by the length, which is 0.4. Okay, so what I'm going to do is I'm just going to say that this is equal to, let's say, 18 over 100. Divide that by 6 over 10. Multiply this by 4 over 10. Okay, so this here is going to give us 18 over 100, and then 6 times 4, which is going to be 24 over 100. Notice how the over 100s are going to cancel, so we have 18 over 24. Looking at those answers, the only sort of answer which could be the answer is 0.75. Okay, well, which way is it the current going to go? For that, we need to apply Fleming's left-hand rule. Remember, FBI, your force is the thumb, and the force should be outwards because gravity is into the page. And if the force is outwards, then if your index finger is in the direction of the actual field, then your direction of the current will be from north to south. Correct answer is G. 33. The wavelength range of visible light is 400 to 700 nanometers. Light with a frequency 6 times 10 to the power 14 hertz is green. Microwave used in cooking have a wavelength of 12 centimeters. Which of the following statements are correct? Light of frequency 7.5 times 10 to the power of 14 hertz is red. Okay, well, let's just calculate the wavelengths, which are going to be 3 times 10 to the power of 8. Divide that by 7.5 times by 10 to the power of 14. Okay, so what is that going to give us? That's going to give us 3 over 7.5. And then what sort of a number we're going to have? We're going to have 8 minus 14, which is going to be 10 to the power of minus 6. So this here is going to give us something which is kind of 3 over 7.5. It's going to be something of the order. Okay, well, this here is going to be 1 over 2.5, which is going to be 0.4 times 10 to the power of minus 6, which is 4 times 10 to the power of minus 7. So red is around 700 nanometers, longest wavelength. So this statement here is not correct. Well, let's just calculate it. So we're going to do 3.0 times 10 to the power of 8, divide that by 12 centimeters, which is going to be 12 times 10 to the power of minus 2. Okay, so the 3 and the 12 are going to cancel, which is going to be 1 over 4, which is going to give us 0.25, 10 to the power of 10. What is that? 2.5 times 10 to the power of 9 hertz. That seems fine. Part 3, EM radiation with a frequency of 2.5 times 10 to the power of 15 hertz can be used in thermal imaging of a building. So thermal imaging means sort of infrared. Well, let's just see. So 3.0 times 10 to the power of 8, divide that by 2.5 times 10 to the power of 15. Okay, so what are we going to get? We're going to get 3 over 2.5. Multiply this by sort of 10 to the power of minus 7. So what is that going to give us? That's going to give us more towards the other range, because 3 over 2.5 is just a bit over 1, 1.2 or something like that, times by 10 to the power of minus 7, which is within the ultraviolet rather the infrared. This seems wrong. Correct answer is C, 2 only. 34, there's a high-speed railway line between two cities that are 60 kilometers apart. Train stops at both cities. Trains accelerate at a uniform rate of 1.5 meters per second to a maximum speed of 120. When braking, it decelerates at a uniform rate of 2 meters per second. What is the minimum time taken by the train to travel from one city to the other? Okay, so the quickest time will involve the perfect acceleration. So in order to work out the time that it needs to accelerate, let's just divide the speed by the acceleration. 1.5, what is that? It's going to be 240 over 3, which is going to be 80 seconds. So this here is the first time during which the train just accelerates. What sort of distance does it cover? Well, let's just do, I don't know, a half times 1.5, a half 80 squared, multiply this by 80 squared, which is going to be a half times 1.5. Okay, multiply this by 80 times, let's say 40, and then I'm going to get rid of this. Okay, so then we're going to have 1.5 times 80 times 40. 1.5 times 4 is going to give me 60, multiplied by 80, which is going to give me 6 times 8 is 48, and then 2 zeros, this many meters, 4.8 kilometers. Okay, now let's work out the time for the deceleration. So the way we're going to do that is v is equal to u, take away at squared, 0 is, final speed is 0 because now we're decelerating, initial speed was 120, minus 2, because that's the deceleration now, multiply this by t squared. Okay, so t should just be equal to 60 seconds. Okay, that makes sense. The first one was 80 seconds, this one is 60. Now, what distance will this thing actually travel? Let's just use this time a half u plus v multiplied by the t. Okay, so what is this going to give us? A half. My initial speed in this case was 120. My final speed was 0. Multiply this by 60. Okay, this here is going to be 30. So it's going to be 30 multiplied by 120. 3 times 12 is 36. And then we have 2 zeros like that. So it's this many meters. Okay, how much distance is left to actually be covered? We've got 3.6 kilometers plus 4.8 kilometers. This here is going to give us 8.4 kilometers. So we need to do 60 take away 8.4. This is such a time-consuming problem. This one here is, what is that? 51.6. Now, okay, let's figure out the time that it takes to cover this at the constant speed. So that's in kilometers. So 5,160 over 120. Okay, so what is that going to give me? That goes, let's see if we can divide by 12. And then we have another 0 here, so what is that, 430 seconds. So total answer is going to be 430 plus 60 plus 80. What is that, 570 seconds. Such a time-consuming problem. Not a hard one, but just really time-consuming. It's so easy to get wrong at pretty much any stage of the problem. 35, a metal block has a mass m, heat is transferred to the block at a constant rate p. Graph shows the temperature against time graph. We're looking for which expression gives the specific heat capacity in terms of the gradient. Finally, an easier one. Okay, so the way we do these is we use energy, which is power times time is equal to mc delta theta. We bring the time over, so we get that power is equal to mc delta theta divided by the time. Now, delta theta divided by t is actually equal to the gradient k, so this here is equal to mck. C is going to be P over M K. What is that? Option D is the correct answer. Skydiver of mass 80 kg is accelerating vertically downwards through the air. At one instant in time, the skydiver has a speed of 5 meters per second. After traveling a further 20 meters downwards, the skydiver speed is increased to 10. What is the average force of air resistance acting on the skydiver over the 20 meters? So once again, we're going to use the fact that change of energy is equal to force times distance. So initially the skydiver had some sort of a potential energy mgh plus some, I don't know, speed v1 squared, and then they just had some sort of a speed which was let's say v2 squared, and this whole thing is going to be equal to force times distance, the distance here just being the height. Okay, so we take the zero line to be that sort of height just after 20 meters have passed. So m times g is going to be 800. Multiply this by 20 plus a half m, which is going to be 40. v1 squared is 5 squared, which is going to be 25. Take away a half m, which is going to be 40. v2 is going to be 10 squared, which is going to be 100. We're just going to evaluate the left-hand side over here before we do f times d. So 800 times 20, that's going to be 16,000, and then another 0, 16,000, plus 40 times 25, that's just 1,000. And then we're going to take away 4,000, what is that? 12,000 plus another 1,000, it's just going to give us 13,000. Is equal to force times by distance, where this here is, 20. Force is going to be 13,000 over 20. What is that? 650. Correct answer is 37. A radioactive nuclide X decays in a single stage to a stable nucleus R. Radioactive nuclide Y decays in a single stage to a stable nucleus S. When a rock formed, it contained equal numbers of atoms of all four nuclide X, Y, R, and S. Half-life of X is T years. Half-life of Y is 2T years. What is the value of the number of atoms of R divided by the numbers of atoms of S at a time 40 after the rock has actually formed? Okay, so let's just summarize. So let's say that initially we're going to call this initial number, which is equal just n. So x goes to R and y goes to S. So what we want to do is figure out the ratio of the number of atoms of R. So initially it was n sort of R types of atoms, and then X has decayed and has gone through 4 half-lives. So what's happened to X is it's gone from N, divide that by 4 half-lives, because its half-life is T and we're talking 4T after, which means that we're going to get N over 2 to the power of 4, which is 16. But that's the number of X which is left. We're interested in the number which is sort of already decayed, which is going to be the number of R atoms that have escaped, so to speak, which is going to be 15 over 16 multiplied by N. Very similarly for the other one. So for Y, it's gone from N to N over 4. Because 2 half-lives have passed. So therefore, for y, we're going to have n plus 3n over 4 left. Okay, now this here will just end up then giving us 16 over 16 plus 15 is going to be 31 over 16n. Divide that by n plus 3/4 of n. What is that going to be? 7 over 4n. N's just cancel. 31 over 16 multiplied by 4. Divide that by 7. 31 over 28. Correct answer is C. 38. This question is difficult and time consuming no matter which way you look at it. Okay, so let me show you one way of doing this problem. So we have a beaker containing 180 grams of water, 25 degrees C, has a 20 gram ice cube at 0 degrees C added to it. No heat is transferred between the water and the surroundings. What is the final temperature after all the ice has melted? With given the specific heat capacity of the water at 4 joules per grams per Celsius, and we're also given the specific latent heat in the correct units. Okay, so let's split the problem into some stages. So the first thing that we need to do is figure out how much energy is required to melt the ice. So for the melting of the ice, we just need E is equal to ml, which is going to be 20, multiply this by 300. What is that going to give us? Well, 6,000 joules. Okay, cool. So we have that energy. Then what's going to happen? Some of that water, the warmer water, will end up dropping its temperature. So let's just say that surrounding water, please don't write like long words, but this kind of is an explanation video as well. So surrounding water drops temperature. Okay, so it's going to drop its temperature by MC. Initial temperature was 25. Take away T. Okay, notice how I've swapped these because it's dropping temperature. So what is that going to be? 180, multiply this by 4. And then what we have is 25, take away T. Shall we just simplify this? 180 times 4 is just 720, 25, take away T. Okay, now it's not over yet because the water that's been melted already will go up in temperature as well, because suddenly you have this water at 0 degrees and its temperature needs to go up because it's surrounded by like warmer water. So let's just say melted ice heats up. I'm just going to break this problem down. Okay, so that's going to be the mass of the melted ice multiplied by the specific heat capacity. So when it had 20 grams, multiplies by 4, and that's going to reach the same temperature, which is T. All of that energy must have come from this expression right over here. Ultimately, these problems are about energy transfer. So the energy of the the warm water, which drops 25 minus T, is going to go to the first of all into the melting. Well, 6,000 joules of them. And then also we're going to have 20 times 4 times T, or 80, multiplied by T into the last bit. Okay, so now we have to do some annoying algebra, I'm afraid. So 720 multiplied this by 25. Okay, multiple different ways of doing that. So 720 multiplied by 20. What is that? 18,000. Okay, take away 720, multiply this by T. This here will be equal to 6,000 plus 80 T. Okay, then let's bring this over onto the other side. So we're going to get 12,000, just bringing the 6,000 over, is going to be equal to 80 T plus 720T, which is going to be 800T. And finally, we have some easier stuff. What is it going to get? We're going to get 120 over 8. What is that equal to? Is equal to T, which is equal to 15 degrees. Correct answer is D. You can also do this problem with like the method of mixtures right at the end, but in my opinion, algebraically, this is actually potentially a little bit more difficult because you have to deal with like loads of decimals, because you have 50 and you have 16.7, so you can't really approximate this. So I think this is probably the easiest way of doing the problem. If you spot something else, please let me know in the comments. Okay, 39. Liquid X has density of 0.8 grams per cubic centimeter. Liquid Y has a density of 1 gram per cubic centimeter. Okay, 8 cubic centimeters of liquid X and 100 of the other one poured into a cylindrical container. They're allowed to settle. The two liquids do not mix or react. The internal cross-sectional area of the container is 20 cubic centimeters. The base of the container rests on a horizontal surface. What is the pressure due to the liquids at a height 4 centimeter above the interior base of the container? Okay, so what's going to happen? Well, we are going to have liquid sort of Y at the bottom. Why is that? Because it has a higher density. I'm going to have some amount of liquid X up here. What are the relative heights going to be? Well, we're just going to use that volume is equal to area times multiplied by the height. So we know the volume of each of them, and we can work out the heights because they have the same cross-sectional area. So the height of, let's say, Y is going to be 100 divided by 20. So what is that? 5 centimeters. Similar, we can say that the height of X is going to be 80 over 20. What is that? Which is going to be 4 centimeters. Okay, so if we are 4 centimeters above the interior, so if we're here, not there, but here, then what sort of pressure are we going to experience? Well, we're going to experience the full pressure of X. Tell you what, I'm just going to work in non-standard units just to get an idea of the answer, and then I'm going to worry about the units right at the end. So what's that going to be? 0.8. I'm just using rho GH multiplied by G, which is 10, multiplied by the height, which is 4 centimeters, plus rho GH for the other liquid, which has density of 1 gram per cubic centimeter. G is 10. I know my units are messed up, but for now, will just give us an idea of the numerical answer. Okay, so this here is going to give us 0.8 times 10, which is 8 times 4, which is going to be 32, plus 1 times 10, which is just going to be 10. So that means that the pressure due to the liquids alone is going to be some multiple of 42 adjusted to units. It's not going to be 42 though, because my units here are wrong, because G is in standard units and these are here are in grams and centimeters. So the correct answer has to be G. I think this is probably the quickest way of doing the problem, hence I've done it this way. Of course, if you want to do it properly, you're just going to say that 0.8 grams per cubic centimeter is equal to, what is it, 800 kilograms per cubic meter, I think, and then sort of like take it from there. But that will be a little bit time consuming, and this is a way forward. Question 40, a pulse of ultrasound travels from one end of a solid uniform rod of length L, starting at a time t is equal to 0. The pulse is partially reflected by a crack in the rod and partially by the far end of the rod. Okay, these two travel back. We're given 2 times t1 and t2, where t2 is the greater one. What is the distance between the crack and the far end of the rod? Okay, so let's just do a quick sketch. So one travel time is going to be from the far end and then kind of like coming back like so. And let's say that the crack is here, and then the other one is going to be kind of there and then back. So this one here would be T1, and then the time that this one here takes is going to be T2. Now let's just write some things that we know. We know that the length is going to be equal to C, which is the speed of sound in this case, T2 divided by 2. Like, it just has to be correct. What else do we know? Let's also see if we can figure out some distances. So we know that this distance, let's call it x, we're not looking for x, is just going to be c t1 over 2. We're looking for this distance here though, because they've said from the far end, so I'm just going to call this distance d. Okay, so d is going to be just the difference in the two. So d is going to be ct2 over 2, take away ct1 over 2. What is that? C over 2, t2 minus t1. Now what I'm going to do is I want to express my answer just in terms of the times. So let's just use this equation, c over 2. And I'm just going to say that c over 2 is equal to, what is that, L over T2. And then I can just plug that back into here. So rather than c over 2, I'm just going to say that this here is equal to L over T2 T2 minus T1. Hopefully that's one of the answers. T2 minus T1 over T2 multiplied by, yeah, so answer E is correct. Okay, 2022, question 21. There's a constant current in the conducting wire. Charge of 250 C passes through the wire in 1.5 minutes. 18 centimeters straight section of the wire. We're given the magnetic field strength. What is the magnitude of the magnetic force onto the wire? Okay, so let's just use F is equal to Bill. We're not given the current directly, but we're given the charge, and then we're also given the time. So I think we're in business. We're going to have 0.15 multiplied by Q, which is going to be 20 over 1.5. Don't forget the minutes. Multiply this by 60. The length of the wire is 18 centimeters, so it's going to be 0.18. Okay, let's do a little bit of cancelling. This here is going to give me a 10. Let's cancel out the 10. That's going to give me a 2 at the top. Let's cancel out the 2 as well, which is going to give me a 30. So I have 0.18 divided by 30. Well, I'm just going to do this over here. This is the same as 18 over 100. Multiply this by 32, which is going to be the same as 3. 5, multiply this by 100, which is the same as 3 over 500, which is just 0.006. There's another 0 here. Correct answer is A. 22. A rider on a roller coaster moves very quickly towards a solid wall. While moving, the rider shouts and hears an echo shouting from the wall. The echo is quieter than the original shout. How do the amplitude and frequency of the echo heard by the rider compare to the amplitude and frequency of the original sound? Okay, so the very fact that it is quieter, that means that the amplitude is going to be lower, so we can get rid of these answers. The frequency, so on the way back, the relative speed between the sound wave and the roller coaster is going to be high because they're both moving in sort of opposite direction. So if the relative speed is higher, the frequency is going to be higher. Correct answer is C. 23, another one of those classic questions. So I'm just going to go delta Q over delta T is equal to K A delta T divided by L. Okay, so what do we want to do? Which two changes independently result in an increase in the rate of conduction? Okay, so how do we increase this? Increase the temperature T1. Well, if we increase the temperature T1, then this one here is at a high temperature, right? So if this one here is at 100 degrees, but this one here is at 80, if we were to bring this up to 90, there's going to be less of a temperature gradient, so this one here is wrong. On the other hand, if we were to increase T2, this will be fine, because if we increase this one to, like, I don't know, 130, then the temperature will be higher. Increase the length of the copper bar, that's not the case, that's going to do the reverse. Increase the diameter, yes, well, it will increase the area. So 2 and 4, correct answer is E. 24. Two resistors are connected in parallel to a 6-volt battery. The two resistors dissipate a total power of 0.15 watts. One of these resistors is removed from the circuit connected to a 12-volt battery. How much charge passes through there? Okay, so what do we have? We have a 6-volt thing. Okay, a couple of resistors across here. I am just going to use the fact that the total power dissipated in the circuit, because that's what we're given, is equal to the PD, which is going to be constant, divided by the total resistance. If I have two resistors of R in parallel, then I'm going to have R over 2 total resistance. So that means that P will be equal to V squared, which is going to be 36, divided by R, multiply this by 2. So R is going to be 36 multiplied by 2 divided by the power, which is what, 0.15. I'm going to write this as 15 times by 100. Okay, this here is going to give me 36 times 2, which is what, 72 over 15. Multiply this by 100. Rather than simplifying this right away, I'll see if I can simplify this later. Hopefully some more stuff is going to cancel out. So the resistor is then removed and is placed on a new circuit. So I need to use probably V is equal to IR to work out the current. So the current will then be equal to that voltage divided by the resistance. Okay, so the new voltage is going to be 12, and then I'm going to flip the fraction. It's going to be times by 15 divided by 72, multiply this by 100. What is that going to give me? Well, let's do a tiny bit of simplification. So we can get rid of the 12, and what we have is a 6 here. So we have 1 over 6 times 15 over 100 divided by 5, we get 3, and then 20 over here, 1 and a 2. So current is going to be 1 over 40 amps. Final step would be to work out the charge, which is going to be equal to IT, which is going to be 1 over 40, multiply this by the time, which is 6 minutes. So multiply by 6, multiply this by 60. Okay, so divided by 2, we're going to get 3. Divided by 2 yet again, we are going to get 3 again. So the 0 is also going to go. We're just going to be left with 9.0 coulombs. Correct answer is G. 25. A small piece of space debris of mass 0.1 grams strikes the International Space Station at a certain speed. The piece of debris comes to rest relative to the space station in time of 0.010. What is the average force exerted by the space station by the piece of debris during this time? Okay, so we're just going to use, anytime I see average force, just use F is equal to delta P over delta T. What do we know? Well, we know that delta P is equal to mass, which is going to be 0.1 grams times 10 to the power minus 3. Initial speed was 15,000 meters per second, so it's going to be 15, multiply this by 10 to the power 3, comes to a rest, so there's no final speed. We just need to divide this by the time, which is going to be 0.01. Those are going to cancel out. That's going to leave me a 10 here. 10 times 15 should give me 150 newtons. Correct answer is E. 26. A block of mass 6 kilograms is pushed along a rough horizontal surface by a constant force of 8 newtons. The block accelerates uniformly from rest. After 4 seconds, its velocity is 2 meters per second. How much work is done against resistive forces during this 4 seconds? Okay, so the first thing that we can probably do is just work out the acceleration of this block. So I'm going to say that the acceleration is equal to delta V over T. So it's gone from rest to 2, so delta V is going to be 2 divided by delta T, which happened in 4 seconds. So that's going to be 0.5 meters per second squared. We can then work out the net force acting on it, which is going to be equal to MA, and that's just going to be 3 newtons. So we have 3 newtons as a resultant force, but this force here will be the sum of all the forces acting on it. So there's going to be a greater sort of forward force and then some sort of a resistive force. So if we have actually 8 newtons really acting in this direction to have a resultant 3 newtons, that means that we need to have a resistive force, which is going to be equal to 5 newtons sort of acting the other way. Okay, so we can just use work done is equal to force multiplied by distance, and then we need to work out the distance that has been traveled. Do we know this? We don't, so we need to calculate it. The way we can do that is just using S is equal to a half A, which is 0.5 times T squared, which is going to be 4 squared. Okay, so it's going to be 5 times 1 over 2 times 0.5 times 4. This gets cancelled. What are we left with? We're left with 2.5 multiplied by 2, which is 5. Multiply this by 4, which is going to be 20 joules. Correct answer is B. 27. Ultrasound is used to find a crack inside of a cuboid block of metal. Ultrasound probe is held in contact with the top surface of the block, perpendicular to the surface. Short pulse of ultrasound is sent into the metal block at time is equal to 0 milliseconds. Reflects both from the crack and the bottom surface of the metal block. Time between the emission of the ultrasound pulse and the return of the reflection of the probe and the strengths of the reflected pulses are measured. What is the distance between the bottom surface of the metal block and the crack? Okay, so imagine that this here is what we're imaging. So we're going to have some larger time t2, which is going to be sort of going there, but then backwards as well. This here is going to be t2. Now let's say that there's a crack here somewhere. We're also going to measure some other time t1. I'm going to call this larger distance L. I'm going to call this smaller distance X. So we know that L is equal to distance multiplied by time, but that's going to need to halve the distance because the overall sound has gone there and back. So L is going to be C. Let's call this T2 over 2, and X is going to be C T1 over 2. Now, the distance we're actually looking for is going to be L minus X, right? Because we're looking for the distance to the bottom of the crack. And this here will be equal to D. So we can say that C T2 over 2 minus C T1 over 2 is equal to D. Let's take a factor of C2. T2 minus T1 is equal to D. Can we figure out what C over 2 is? Oh wait, we are actually given what the speed of sound actually is. So it's 5,000 meters per second. So we can just calculate this directly. 5,000 over 2 is going to be 2,500. Now we can see that T2 is 0.2 from the graph. Take away, what is that, 0.12. This here is equal to the distance. So what is that equal to? 2,500. Multiply this by 0.08. Multiply this by 10 to the power of minus 3. So this here is equal to 2,500. Multiply by 8 over 100. Times by 10 to the power of minus 3. Those here can go. We're going to have 25 multiplied by 8, what is that, 200 times 10 to the power of negative 3. Correct answer is A, 0.2 meters. 28, power is applied to an electric motor at 0.8 kilowatts. The motor has efficiency of 60% and is switched for half an hour. How much energy is wasted? Okay, so let's find just 60% of 0.8, which is going to be 0.6. Multiply this by 0.8, which is going to be 6 over 10 times 8 over 10, which is going to be 0.48, and this here is in kilowatts. Okay, so how much is actually wasted? Well, it's going to be 0.8, take away 0.48, which is going to be 0.32 kilowatts. Let's write that 10 to the power 3 because we're going to be working in joules, are wasted. The total energy, which is equal to power times time, is going to be 0.32 wasted times by 10 to the power 3. Multiply this by, how long is that, for half an hour? So half an hour is going to be 30 minutes. Each of them has 60 seconds. Okay, right, so 0.32 multiply this by 3, which is that going to give me 0.96. Multiply this by another 10, which is like 10 to the power of 4. Multiply this by 60. So this here is going to be equal to 96 times 10 to the power of 2. Multiply this by 60. Okay, so 9 times 6 is going to start with a 5, and additionally this answer is going to be quite big because we had a 60 over here. 96 times 100, so it's not going to be 576, it's going to be the larger one. Correct answer has to be G. 29, the circuit diagram shows a circuit that includes 2 ammeters and a resistor R. Readings of the ammeter are shown. What is the resistance of the resistor R? Okay, so let's work out what are the other currents. So 3.3 is going to split into some current through here and then 1.8 here. So 1.8 plus 1.5 amps is going to give us sort of 3.3 amps after those two junctions. Okay, so do we know the voltage across the other one? Well, we can calculate the voltage across here because that's just going to give us 1.5 multiplied by 3 because V is equal to IR, so it's going to be 4.5 volts, which means that the voltage across this one here will also be 4.5 volts. Now I can just use R is equal to V over I, which voltage is, let's just write that as 9/2, multiply this by the current, what was the current? Divided by 1.8 amps, which is divided by 18/10, which is the same as 10/18. Okay, well, let's do a little bit of cancellations. This here is going to give us 10/4, which is 2.5 ohms. Correct answer is B. Question 30, graph shows the potential difference plotted against current for a filament lamp and a resistor. Okay, so here they are. I always need to draw a little bit of a diagram just to get an idea of what's actually going on. Okay, so we've got some IV characteristics. So both the filament lamp and the resistor. The lamp and the resistor are connected in parallel with each other to a 6-volt power supply, and the current in the lamp is recorded. Okay, in the second circuit, the lamp and resistor are now connected in series. Okay, so we have 2 circuits. Brilliant. One is like that, one is like that. The potential difference across the lamp V is recorded. The current is now 0.18 in the second circuit. Okay, 6 volts for the power supply, so it's going to be 6 volts across here. Okay, so this here is 6 volts and this here is 6 volts as well. Okay, so if we are at 6 volts, we can probably just work out some currents in the parallel circuit. So, okay, this one here for the resistor, and then this one here for the filament lamp. Okay, so the value of I, which is the one in the filament lamp, well, that's just sort of between 0.3 and 0.4, so it's going to be 0.35. Okay, 0.35 amps across here, so we can get rid of all of these answers. What is the value of V in the second circuit? So we have 0.1 amp in the circuit. We're looking for the value of V, which is the potential difference across the lamp. Well, they're going to share the exactly same current, so if it's 0.18, so I don't know, somewhere over here, we can clearly see that the potential difference across the lamp is going to be smaller than 2. This means that the correct answer has got to be D. 31. A child is bouncing a ball of mass 0.16 kg vertically up and down on a bat. Each time the ball hits the bat during the contact is 0.2. Speed of the ball immediately before hitting the bat and immediately after it loses contact with the bat is 4 meters per second. What is the average contact force between the bat and the ball during the collision? Okay, so this question is all about the meaning of a resultant force. So during contact, the net force is equal to the sum of all forces. Now, what sort of forces are acting on this thing? So we have some sort of a force, let's call it force from the bat, and then we also have sort of mg going downwards. The upward force needs to be bigger. So the rate of change of momentum is only going to give us the overall force. So this here is going to be equal to the F bat take away mg. So that means that F bat will be equal to F net plus mg, which is delta P over delta T plus mg. Can we work out the rate of change of momentum? I think we can, because we know the mass, 0.16. Now, what is the change of speed? If we're going from 4 to minus 4, one way to think about it is going to be 4 minus 4, which is going to be equal to 8, depending which way you take, positive or negative, but the magnitude is going to be sort of 2mv. So it's going to be multiplied by 8 divided by the time. What is the time? 0.2, like that. And then we need to add in mg, which is going to be 0.16 times 10, which is 1.6. Okay, let's do a little bit of cancellation. So this one here is going to be a 4. What do we have at the bottom? So 2/10. Let's just write that as 0.1, which is 1/10. So that's going to be 0.16 times by 4, which is 0.64 times by 10, which is going to give me 6.4 plus 1.6, which is going to give me 8.0 newtons. Correct answer is E. 32, a transverse wave on a string has a speed of 500 meters per second. The horizontal distance between 2 points P and Q on a wave is 4 meters as shown in the diagram. At time t is equal to 0, point X on the string is at its maximum displacement of 6 millimeters above the equilibrium. What is the displacement at point X at a time t is equal to 7 seconds? Okay, so what do we know? We can probably find the wavelength, because the distance between P and Q on the wave is 4 meters. So P and Q is 2 wavelengths, so that means that lambda has to be equal to 2 meters. So then I can probably use that V is equal to lambda over the time period. So the time period will then be equal to lambda over V, which is going to be 2/500. So what is that? 1/250, which is equal to 4 times 10 to the power minus 3, which is equal to 4 milliseconds. Okay, so the time period is 4 milliseconds. After a time of t is equal to 7 milliseconds, we would have covered one time period plus 3/4 of a time period. Why is that? Because we have sort of 4, which is one time period, plus 3/4 of t, which is what's remaining. Now, after 3/4 of a time period, if we have started at the top, apologies for the not very good diagram, but if let's say that this here is 3/4, initially we start up here, that's a quarter, that's another quarter, and that's 3/4. So we should be at 0 millimeters. Correct answer is C. 33, a neutral atom Q of a particular element contains a total of 20 particles, protons, neutrons, and electrons. The table shows information about the number of particles from relative charges of 4 atoms of ions W, X, Y, and Z. Which of these atoms could be of a different isotope to Q, but of the same element as Q? Okay, so let's consider these. Atom or ion W, number of particles is 21, relative charge of atom or ion is 0. This one is fine. So the first one just simply corresponds to gaining a neutron. Okay, X. So number of particles is 21. The relative charge of the atom or ion is -1. So this here means that it must have gained an electron only. So this here is tricky in the wording, because even though this particle is totally possible, it is not actually an isotope. And the question is asking us which of these could be of a different isotope. So X is not okay. Y, 20 particles, we had 20 to begin with, plus 1 on the charge. Yep, this one here seems fine. So for instance, it would have, what does that technically correspond to? It means that we've lost an electron, but if we've gained another particle, we've probably gained a neutron, like that. 22 and a 0, probably, yeah, this one here is going to be fine. So that one here was going to correspond to gained 2 neutrons. So this one here was fine, this one here was fine, this one here was fine. Correct answer is G. 34, radioactive isotope X undergoes single beta decay into the form of the stable isotope Y. Sample consists only of X and Y. The graph shows how the mass of Y present in the sample varies with time. After a long time, the mass of Y in the sample becomes a constant of 50 G. What is the half-life of X? Okay, so this here is an unusual way of finding a half-life, but what I'm going to do is I'm going to show you a really sort of easy way of dealing this problem. I'm going to take my time with this question because I want to write it out, because this method is not commonly taught. The first thing that you want to do is find the final amount and the difference. So in this case, the final amount is, what is it, 50. And the difference from the start is going to be 30, right? So it's going to be 50 minus 20, which is going to be 30. Then what we want to do is find t half, so basically we have that amount. So we're going to find 30 over 2, which is going to be 15. And then what we want to do is figure out add this to the initial time. Add this to the initial mass. Add 2 to the initial mass. And find the half time, the half-life. And find t half. So let me show you once again. The first thing you would do is find where this thing starts to approach an asymptote, which is around 50. Subtract it from the initial, which is 20. So half of that is going to be 15. Basically find the halfway value of those 2 points, which is going to be here somewhere. And then find the time that this thing corresponds to, which is just going to be equal to 2, which should be the half-life. 2 minutes. Correct answer is C. 35. A piece of metal of mass 50 grams is thermal equilibrium in a hot liquid of temperature T. The metal is removed from the liquid and immediately placed in 100 grams of water that is at 20 degrees. Water is stirred and reaches a final temperature of 26 degrees. And we have a whole bunch of specific heat capacity. What is the temperature of the hot liquid? Okay, so this question is ultimately about the energy from the metal going into the water. Okay, so the energy of the metal, what is that going to be equal to? So that's going to be equal to the mass of the metal multiplied by the specific heat capacity of it multiplied by temperature minus 26. So it was initially at a temperature T and then it's gone to temperature 26. That's why I've written it as T minus 26. So this here is going to go to M water, C water, I don't know, 26, take away 200, take away 20, excuse me. Okay, so now we can probably plug in some numbers and see if we can figure out what T actually is. So, okay, 50 grams, what is that going to be? 0.05, multiply this by 350, T minus 26 is equal to mass of the water is 100 grams, 0.1 times 4,200, to multiply by 6. Okay, right, let's see if we can simplify the left-hand side. We're going to have 5 over 100 multiplied by 350. That thing can get cancelled. T minus 26. 5 over 10 is half of that, so half of 35, what is that, 17.5. T minus 17.5 times 26. This is not looking good, it's looking a little bit too complicated. What is that going to be equal to? Well, 0.1 times 4,200 is going to give me 420. Multiply this by 6. Okay, so let's see, 17.5 T is going to be equal to 420 multiplied by 6, take away 17.5, multiply this by 26. Let's just divide by 17.5, so T is going to be 420 multiplied by 6 divided by 17.5, take away... the takeaway here should be a plus. I've just plotted that, so plus 26. Okay, so what I'm going to do probably is 420 times 6. What is that going to be? T will be 252 over 17.5 plus 26 degrees. Can I approximate this? Okay, 252 over 17.5 is about 25, sort of over 18. It's going to be either C or D, but they're a little bit too close for my liking to approximate. if you can approximate better than me, you can probably pick either C or D pretty quickly. Let's just multiply this. So 252, this here is going to be 540 over 35 plus 26. So 5,000 over 35. This here is about 140 plus 26. So this is much closer to 170 degrees. These approximations can be quite important. You can see later that this here is actually equal to 144. So the answer is basically exactly 170. Okay, next one. A ball magnet is placed at position X close to one end of a coil on the axis of the coil as shown. The graph shows how the velocity of the magnet varies as it's moved rapidly to position Y. The magnetic field of the bar magnet still faces the coil and the magnet is in position Y. Which graph represents how the induced voltage moves? Okay, so if the velocity is changing direction, the rate of change of magnetic flux should also change direction, which means that the induced voltage should change direction. So that means we need to have negative voltage. So we can't have that, we can't have that, we cannot have that. So, okay. The first thing to note is that the induced voltage should be lower as it's moving away because the magnitude of the magnetic flux will decrease with distance. So because of that, correct answer has to be D. This one here is sort of unphysical where it increases the further away you are. This one here is constant. So yeah, correct answer is D. 37, a smaller slider of mass 30 grams is at rest of the bottom of a frictionless slope and in contact with a light uncompressed spring as shown. Spring is compressed by 5 centimeters and the slider remains in contact with it. Spring is released and causes the slider to rise up the slope to a maximum vertical height of 20 centimeters. Slider is replaced with another mass 20 grams. Spring is now compressed by 15 centimeters. To what maximum vertical height does the new slider rise after it's been released? Okay, so here's probably the easiest way to solve this question. Probably I'm going to say a half kx squared is equal to mgh. This is what ultimately determines how far this thing is going to go. So let's just rearrange this for h. So h will be 0.5 kx squared divided by mg. Now, how do all of these things sort of actually change? So if we've gone from a mass of 30 kilograms to a mass of 20 kilograms, then the sort of mg would have sort of decreased by 2/3. That means that the height will end up sort of increasing by 3/2. What about x? So x has gone, so initially it was compressed by 5 centimeters and now it's gone by 15. It's gone to 15. So x would have increased by a factor of 3, which means that x squared will increase by a factor of 3 squared, which is 9. So the overall effect of the initial height is going to be this factor, 3/2 times 9. So all we need to do is multiply the initial height by this. And what are we going to get? We're going to get 9 times 20 is 180. Multiply this by 3/2, which is going to be 90 times 3, which is going to be 270. Correct answer is F. 38. A tall, smooth cylinder contains air at atmospheric pressure 1 times 10⁵. The density of the air in the cylinder is 1.2 kg per meter cubed. We have a heavy piston is now placed in the top of the cylinder and allowed to fall slowly downwards, compressing the air until the piston rests in equilibrium. Mass of the piston is 50 kg. We have the cross-sectional area. What is the density of the air when the piston rests in equilibrium? Okay, so when the piston rests in equilibrium, the force the force due to the differences in pressure on either side of the piston is going to be equal to mg. So that means that delta P is going to be equal to mg/A. So mg is going to be equal to its mass, which is going to be 50 times 10, which is going to be 100. That's the force divided by the cross-sectional area, which is going to be 0.02. 2, which is going to be 2, then put a factor of 100 here. What is that going to give me? That's going to give me 25,000 pascals. Okay, but the idea here is that we need to add that to the already existing air pressure, because we had sort of air pressure here and then air pressure here as well. So the inside here, we're going to get the air pressure plus that additional factor of delta P. So we can even call it the real pressure, if you like, is going to be 1.25, multiply this by 10 to the power of 5. So the pressure increases by a factor of 1.25. This means that the volume should decrease by 1.25. But this question is asking us about the density, and density is inverse proportional to the volume. So if the volume has gone down by sort of 1.25, the density will increase by the same factor as the pressure. They're fully proportional at a constant mass. So all we need to do is get the original density, which is 1.2, multiply this by 1.25. And this here should give us answer E, which is going to be 1.5 kilograms per cubic meter. 39, there are two types of earthquakes, P waves and S waves. When an earthquake occurs, both types of waves are produced at the same time and follow the same path. P waves travel outwards from the source at 5 kilometers per second. S waves traveled out at 3 kilometers per second. A seismic monitoring station takes P waves 30 seconds before the S waves. How far have the waves traveled from the source of the earthquake to reach the seismic monitoring station? Okay, so tell you what, I'm just going to say that the distance is equal to 5 kilometers multiplied by t, but it's also equal to 3 kilometers multiplied by t plus 30, just working in kilometers per second. So what's that going to give me? 2t is equal to 90, t is going to be equal to 45. The distance though was 5 times 45, which is going to be 225 kilometers. Correct answer is E. Question 40, a solid cuboid has a mass of 32 kg and a density of 4 grams per centimeter cubed. Tell you what, shall we just work out the volume? So the volume here is going to be mass over density, which is going to be 32,000 grams divided by 4 grams per cubic centimeter. So what is that going to give me? 8,000 cubic centimeters. Okay, when the cuboid rests on one of these faces on a flat horizontal surface, the pressure on the surface due to the cuboid is 1.6. Well, let's just work out the area. So pressure is equal to force over area. Area is going to be equal to F over P, which is going to be 320 divided by 1.6, which is going to be 200 square centimeters. When it rests on another of these faces, the pressure on the surface due to the cuboid is 0.8. So if the pressure has gone down by a factor of 2, this means that the area must have increased. So this means that the area here, let's call it A2, is going to be 400 square centimeters. Okay, what is the pressure on the surface due to the cuboid when it rests on the third of these faces? A little bit of a trick here, but we can probably use the fact that that V is equal to ABC, where these are just the 3 lengths. And then we can use that V is equal to sort of ABC squared, which is just equal to A1 times A2 multiplied by A3. Now the volume squared is just going to be 8,000 squared. So A3 is just going to be equal to 8,000 squared divided by A1 times A2, which is going to be 200 times 400. Okay, so it's going to be, I just always write these as 8,000 multiplied by 8,000 divided by 200 times 400. Let the cancellations begin. Okay, so what are we going to get? We're going to get 40 multiplied by 20, which is just going to be 800. We're looking for the pressure though, so the pressure is gonna be twice as low because the area is twice as high yet again. So it should be A, 0.4 newtons per square centimeter. Of course, you could always just calculate this as F over A, which is 320 over 800, if you're not convinced. Okay, last paper, 2023, here we go. An object of mass m and weight w on the moon. The moon has no atmosphere, object is released from rest. What expression gives the speed of the object as it reaches the surface? So the easiest way is just going to be to use mgh is equal to a half mv squared as normal. We're going to get that v is going to be equal to the square root of 2gh. Notice that there's no g in our final answer, so we can just use that w is equal to mg. G is going to be w over m, meaning that v will be equal to the square root of 2w over m multiplied by h. Correct answer is G. 22, a spaceship of mass 10,000 kg moving at 2 meters per second relative to a space station. Spaceship is captured by a robotic arm attached to a space station, brought to rest by a force of 1,000 newtons. How far will the spaceship move in its initial direction relative to a space station while the force is being applied? Okay, so we're just going to use that work done is equal to force times distance, which is equal to a change of energy. And because the change of energy is going from that initial speed to 0, that's just going to be equal to a half mv squared. Okay, so force times distance is just going to be 1,000 multiplied by some distance d that we are looking for, multiplied by half m, which is going to be half of 10,000, which is 5,000, multiplied by v squared, which is 4. Let's do a bit of cancellations. D is just going to be equal to 20 meters. So correct answer is F. 23, a heater is connected in series with a DC power supply, a variable resistor and an ammeter in the circuit shown. The variable resistor is adjusted until the reading of the ammeter is 0.5 amps and the resistance to the heater is 8 ohms. How much energy is converted to thermal energy in 5 minutes? Okay, so we have 0.5 amps across here. We know that this here is 8 ohms. So what does that mean? We're going to have 0.5 times 8, which is going to be 4 volts across here. Energy is just equal to VIT, which is going to be 4 times 0.5, multiplied by the time, which is going to be 5 times 60, which is going to give us 2 times 5 times 60, which is going to give me 10 times 60, which is going to give me 600. Correct answer is D. 24, circuit is set up as shown. All 3 resistors are identical. Okay, when the switch is open, the reading on the ammeter is 1 amp and the power transfer for the battery is 1 watt. When the switch is closed, what is the new reading of the ammeter and what is the new power transferred from the battery? Okay, so I can immediately tell you that when you add new branches in parallel, the current through here is going to remain the same at 1 amp, but the total power will end up increasing. This is because the total resistance of the circuit goes down at a constant voltage, so more power is drawn out of the circuit to bring out some extra current through this branch. Now, what is the new power actually going to be? Well, how much will the resistance of the circuit actually change? So the resistance initially, let's see what it was. Well, we can just use P is equal to I squared multiplied by R. It's all ones here, so that means that R is going to be 1 over 1, which is just going to be 1 ohms. Now, when the switch is closed, we are going to have R total, which is going to be 1 over R plus 1 over 2R raised to the negative 1. This is something that's appeared on the ESAT before, and actually remember this, that it's going to be equal to 2 over 3 R now. Okay, so that means that the total resistance will go down by that factor. So because power is equal to V squared over R, where this here is R total, if R total essentially has gone down by 2 over 3, the power will increase by the reverse factor, which is 3 over 2. right? So 3/2 times the initial power, which was 1 watt, is going to be 1.5. Correct answer has to be F. A car travels for a total time of 20 seconds. For the first t seconds, the speed is 5, and for the remainder of the journey, it's 10. Average speed of the whole journey is 8.5. What is the value of t? Probably the easiest way to do this question is to think about this in terms of proportions. So I'm going to do t times 5/20. Plus, if the total time was 20, I'm going to do 20 minus t over 20. Multiply this by 10, which is the remainder of the speed. And this here is going to give me an average of 8.5. Okay, so what is that going to give me? That's going to give me t/4. Plus 200/20, like that, minus 10t/20. And this here is going to be 8.5. Okay, let's simplify this a little bit. t/4 plus 10 minus a half t is equal to 8.5. t/4 minus a half t is equal to 8.5 minus 10, which is minus 1.5. Okay, so t/4 minus 2/4 t is equal to 1.5. So what is that going to give me? Minus 1/4 t is equal to minus 1.5. T is just going to be 6. Correct answer is B. 26. A spring is initially unstretched. A force F is used to stretch the spring. The extension X and the energy stored in the stretched spring are measured for different values. So we have a graph of E. Now notice something quite sneaky. It's a graph of E against X squared. What is the magnitude of F when the spring stores this much energy? Okay, so I'm going to use the fact that, well, E is equal to a half Fx. And I could probably figure out what the force is just by using 2E divided by X. Okay, now X is going to be equal to 25 square centimeters. So that means that in this case, my X will actually be equal to 5 centimeters. So that's going to be 5 times 10 to the power of minus 2. This is going to be equal to twice the energy, which is in standard units, 0.015. Okay, so what is this going to give me? That's going to give me 2/5. Multiply this by 0.015. Multiply this by 100. Okay, that's going to be 2/5. Multiply this by 1.5, which is going to be the same as 3/2. Which is gonna give me 3/5, which is 0.6. Correct answer is B. 27. The nuclide symbol for helium-3 is that nuclear development X has double the nuclear charge. So what is that going to be? 4, and 4 times the mass of helium-3, which is going to be 12 over here. The nuclear decays by a single beta decay. So anytime we have beta minus emission, what we get is a neutron turning into a proton, then we get the beta minus, and then the antineutrino, and so on and so forth. But Z is going to be 5 here, and then a 12. The upper number remains the same because the neutron and proton overall number remains the same. Let's see, this here is E. Okay, 28. A solid cylindrical metal bar has a uniform cross-sectional area of 12 cubic centimeters and a volume of 180 cubic centimeters. Bar rests on a horizontal surface of one of its circular faces. Pressure on the surface due to the bar is 0.45 newtons per square centimeter. What is the density of the bar? Okay, so, well, density is equal to mass over volume. I do know the volume, so all I need to do is see if I can figure out the mass of the bar. And because my answers are in grams, I'm going to need to make sure that my mass is in grams as well. How do I figure out the mass? Well, probably from the weight. So I'm just going to use the fact that the force is going to be equal to pressure times area. Now I do have, I've got pretty much everything. So the force is going to be equal to 0.45. Multiply this by the area, which is 12. So the 0.45 is per square centimeters, the area is in square centimeters, so that bit's going to cancel. The force is going to give me 45 over 100, multiply this by 12. Okay, so this here is going to give me a 6, this here is going to give me a 50, so I have 45 over 50, which is the same as divided by 5, 9 over 10, multiply this by 6. 9 plus 6 is 54, so what is that going to be? 54 over 10. So this whole thing is equal to the force, but the force is actually equal to mg. This of course means that m is going to be 54 over 10 divided by 10 again for g, which is going to be 54 over 100, which is going to be 0.54 kg. This is in kilograms. We want the answer to be in grams, so it's going to be 0.54 multiplied by, to convert that from kilograms to grams, by a factor of 1,000, so it's going to be 540 divided by the volume, which is going to be 180. Correct answer is B, 3 grams per cubic centimeter. 29, a ray of light directed horizontally towards two long plane mirrors X and Y, which are both 45 degrees to horizontal. After two reflections in a ray is traveling horizontally again. Mirror X is now rotated clockwise through less than 45 degrees. Okay, this seems a little bit suspicious, through less than 45, so not by 45. After this rotation, mirror X makes an angle with a horizontal where theta is less than K. Direction is unchanged. In what direction should be rotated in order for the still horizontal and traveling to the right after reflecting from mirror Y? Okay, so the basic principle is that whatever we did to mirror X, we should do to mirror Y. Now we need to figure out what was actually the angle of rotation. So originally it was at 45 degrees, so that means that the new angle of rotation, which is going to be this one, is going to be 45 take away theta, or 45 degrees take away theta. And we need to make sure that we rotate it in the same direction for them to remain parallel. In other words, we just kind of need to move that over here. So we need to rotate it this way, which is clockwise, through an angle of 45 minus theta. Question 30, two samples of pure radioactive isotopes X and Y decay with half-lives of 2 and 3 days respectively. Both X and Y decay in single step into different stable isotopes. Initially, the number of atoms of X is twice the numbers of atoms of Y. After how many days are the expected numbers of atom X and Y equal to each other? Okay, so let's just say that this one here is N, this one here is going to be 2N. One has a half-life of 2, the other one has a half-life of 3. Okay, so I am going to pick the first multiple of 2 days and 3 days because it's a multiple of both of those half-lives. So I'm going to pick 6 days, and then I'm going to see what's happening. So if I have X and Y, X would have started at 2N, and then how many times would it have decayed? So it would have gone in 6 days. It would have gone over 3 half-lives, so we need to have divided by 2 to the power of 3. It would have halved 3 times. The Y, though, would have halved twice, so what we're going to be left with is N over 4. I think we're about to get lucky with the number that we've picked. So this here is going to be N over 2 to the 3, which is 8. And there's a factor of 2 here. This one here is N to the power of 4. So yeah, after 6 days, then they will be fine. So if we didn't get the same number, I would try 12, and then if not, I would try and solve this mathematically. But I think this is probably the easiest way to tackle these. Pick a common multiple. Question 31. 2 stones are held at rest at the same height at the top of a cliff. One stone is released and falls freely under gravity. A time t later, the other stone is released and falls freely under gravity. Which graph shows how the vertical distance separating the stones varies with time for the moment the first stone is released before the first stone lands? We're assuming that air resistance is negligible, which is going to be crucial. Okay, so the separation initially will essentially be the height coordinate of the first stone that's released, which is going to be given by essentially h, or separation is equal to a half gt squared. So what we're doing is we're expecting sort of a parabola, not a linear time. Okay, so it's not going to be this one, it's not going to be this one, it's not going to be this one. It could be sort of some of these. Okay, now after the other stone is released, it's going to acquire some acceleration, but it will always be moving at a speed which is slower than the other one, because the other one is being accelerating for longer. So that means I'm not expecting any of these flat regions like that. So if that's the case, I'm stuck between A and C. Now with C, notice how the C is linear as well, so we can get rid of this one. Yeah, correct answer has got to be A via the process of elimination. I think this is the easiest way for this one. Okay, 32. A large flat metal plate is coated on one side with a layer of thermally insulating material of the same thickness alpha as the metal plate. The uninsulated top surface of the metal plate is maintained at a constant temperature T1. The bottom surface of the insulating material is maintained at a constant lower temperature T2. The system is in equilibrium. The diagram shows this arrangement. Which graph could show how the temperature varies with distance from the top surface to the bottom surface? Okay, so one of the things to note is that the temperature at the point where they meet, which is alpha, should be exactly the same. So this means we can pretty much get rid of this one. Now, how will the temperature differ? So we need T2. So it's not going to be just like a general sort of decrease, because they're different materials. They're going to have different thermal conductivities, so they're going to have different temperatures inside. It's also not going to be constant within the insulator. Okay, so which graph is going to have the steepest gradient? So imagine you have sort of a hot piece of metal. If that's the case, if you were to heat up one of the ends, the other end will likely get warm very quickly. So metals in general do not have a very high temperature gradient, which is almost a little bit counterintuitive. Because of this, the correct answer is A. On the other hand, you may have an insulator. I don't know, for instance, it could be something like a cooking pan, in which there's a very great temperature gradient on the insulator part, let's say the handle, in which the temperature can do something like this. But yeah, correct answer is A. Question 33. 10 grams of ice at 0 degrees is added to 20 grams of liquid water at 30 degrees. The mixture reaches thermal equilibrium. What is its equilibrium temperature? Okay, so what is actually happening here? There's going to be some energy released from the change of temperature, which is going to go into the ice. So how much energy are we talking about? Well, the total energy pool available is going to be MC change of temperature. So the change of temperature is going to be equal to the mass of the liquid water, which is about to change its temperature and give away that energy. Multiply this by 4.2. The change of temperature was starting off at 30 degrees C, so the total change of temperature it can offer is going to be 30 minus 0, which is 30. Okay, so what is that going to give me? 20 times 4.2 is going to be 84. Multiply this by 30 is going to give me 2,400 plus 120, which is 12,520 joules of total energy available. Okay, now how much energy is actually going to be needed to melt the ice? Well, we can say that the energy to melt the ice is just going to be equal to ml, which is going to be equal to 10. Multiply this by 330, which is going to be 3300. Now, you can probably see a problem that this here is the total energy available, and this is what's required to melt the ice. So the ice does not fully melt. In other words, the equilibrium temperature is just 0 degrees. 34, the voltage output of a power station is stepped up using a transformer before the power is transmitted to a distant town. The primary core of the transformer has 300 turns and the secondary core has 1,500 turns. Okay, in the town of step down transformer, so that's a separate transformer. This here is transformer 1, it's called T1. In the town, we have a different transformer, reduces the voltage supplied by the transmission cables to 33,000 volts for distribution within the town. Step down transformer supplies a current of 1,500. Okay, current transmission cable is 450. Both transformers are ideal. Okay, that's useful. What is the voltage output of the station? So from here, we kind of need to go back to here, and then we need to go back to here to the actual power station. Okay, so let's have a look at the first transformer, which is going to be between the transmission cables and the town itself. Okay, so for those ones, I'm going to use V1, I1, which is the sort of input power to that transformer, which is going to be equal to V2 multiplied this by I2. Okay, what do we know? We know that I1 is going to be 450. That's within the transmission cables. We also know that I2 is going to be 1,500, and we know this one here is 33,000. So we can work out what our V1 is, which is going to be V2 I2 over I1. So what is it going to give me? 33,000. Multiply this 1,500. Divide this by 450. Okay, so we can do a bit of cancellation. This here is going to give me a 3. So what is that? 110,000 volts. Okay, so this here is the voltage that's going to be V1 within the transmission cables. So there was also, though, another transformer, and we're going to use that to figure out the voltage within the actual station. So this is the product of a step-up transformer, and the ratio of the step-up is 1,500 to 300, which is a ratio of 5:1. So the voltage within the actual station, let's call it V, it's just going to be this one, 110, which was already kind of like stepped up. So we need to find the original voltage, we need to divide by 5, basically 22,000 volts. Correct answer is C. 35. This here is a tricky one, but I'll show you a little trick. A physicist introduces a thin piece of glass into the path of a laser beam in order to delay the beam. Light of a laser beam has a single wavelength L in the air, while the beam is inside the glass. It completes 10 more complete oscillations compared to the same beam passing through the same thickness of air. Speed of light of c is that. What is the thickness of glass? So anytime we're looking for sort of complete oscillations, or it's kind of like a number of oscillations, it will be very useful just to write that the number of oscillations is typically a ratio of the length divided by the wavelength, or the time period, or some sort of a time divided by the time period. In this case, we're given distances, so I'm going to take the distance d and I'm going to divide it by L. This here is my number of oscillations because the wavelength is just L. Okay, now let's use c is equal to f lambda. Frequency is going to be c over lambda. The speed of light will decrease by a factor of 2 over 3, which means that the wavelength will decrease by 2 over 3. Now, this means that the new number of oscillations is going to be with the reverse factor, so it's going to be increased by 1.5. So because the wavelength has decreased, you can fit more waves within that space, so it's going to be 3 over 2 times d. Okay, we can now just compare them because we know that they differ by 10. So we can just go 3 over 2d is equal, d over L, sorry, and there's an L here, is going to be equal to d over L plus 10. And now we've got a relatively straightforward equation. So we can go 3 halves d over L minus d over L. What is that going to give me? A half. D over L is equal to 10. D is going to be equal to 20L. Correct answer is E. 36, a transverse wave with an amplitude of 3 centimeters travels along a stretched string. The wave has a frequency of 12 hertz and wavelength of 0.25. What is the average speed of the particle as the string oscillates during a time of 2 seconds? Okay, so an individual particle across a wave is going to go up to the maximum amplitude, is going to come down to the equilibrium, it's going to go down to the negative amplitude, then back up to the equilibrium. So over one cycle, it's going to travel a total distance of 4 times the amplitude in one time period. So the average speed of that particle is going to be 4 times the amplitude, which is 3 centimeters. The units are just in centimeters. Divided by the time period, we're given the frequency, which is going to be 1 over 12. So this here is going to be 4 times 3 times 12, which is 12 times 12, which is 144 centimeters per second. 37, a copper rings with small gaps rests in a uniform horizontal magnetic field. Ring lies in a plane of the page and direction of the magnetic field is horizontal from left to right. You supply voltage XY such that X is connected to the positive terminal. So this here is the positive. Which statement describes the motion of the ring immediately after the voltage is applied? Okay, so current always flows from positive to negative. So if we look at this section over here, the current will be this way. And this section here, the current will be this way. And if we apply Fleming's left-hand rule, we are going to find out that the force in this section is out of the page. Here is going to be into the page, which means that it's sort of going to rotate like this. The statement which best describes this is H, the ring rotates on about an axis, which is this one over here, that is in the plane of the page, but is perpendicular to the field because this angle here is basically 90 degrees. Correct answer is H. 38, a battery and 2 resistors X and Y connected in series. Okay, what do we know? We know that the power by the battery, transferred by the battery is 6 watts. Resistance of X is 10. The voltage across Y is going to be 4 volts. What is the current in the circuit? Okay, so let's just call the total voltage V. I'm going to call this one Vx. I'm going to know that V is going to be equal to Vx plus 4. So I know that V is going to be IR, which is going to be I times 10 plus 4. So then we also know that 6 watts in total power is equal to VI. So 6 is going to be equal to V, which is I times 10 or 10I plus 4. Multiply this by I. Okay, so 6 is going to be equal to 10I squared plus 4I. 10I squared plus 4I take away 6 is equal to 0. This is actually factorizable by splitting this middle term into 5I and into 5I and then take away I. So this here is going to give me, what is it, 5I minus 3, I think. I plus 1 is equal to 0. So the current cannot be negative, so we're just going to take this root, which is 5I is equal to 3I is going to be 3 over 5. Correct answer is B. 39, a cubic block of wood of side length L floats in the water with the top face of the block horizontal and above the surface. The block is displayed downwards by a small distance L over 10 without being fully submerged. Density of the wood is 0.8 and density of the water is 1 gram per cubic centimeter. What is the initial acceleration of the block after it is released? Okay, so the thing to realize is that initially it's floating. So how much of the block is going to be submerged? So the submerged ratio will be equivalent to the ratio of the actual density. So this is a very useful thing to remember. If the ratio of the density is 0.8 to 1, this means that 0.8 or 80% of the block will be submerged. Okay, so if 80% of the block is submerged normally, basically all of those forces are going to be balanced. What extra force are we going to get? What extra buoyancy force are we going to get? I'm going to say that the extra buoyancy force is going to be equal to the extra submerged mass multiplied by G, which is essentially Archimedes' principle. Okay, so that extra delta U is going to be equal to the density of the water multiplied by G, and then how much of a volume has been submerged? Well, one dimension is going to be L over 10 times L times L. Okay, well, what is that going to be equal to? Rho L is, this here should really be the density of the fluid, of the water, really. Wood and water both start with W, so let me just write fluid just so that there's no confusion between the water and the wood. So okay, the density of the water is 1 times 10, then multiply this by L cubed over 10. Okay, so what is that going to give me? That's going to give me 1 L cubed. This extra force, we are going to set that equal, because that's the only force that's going to cause acceleration. We're going to set that equal to the overall mass of the cube, which is going to be the mass of the wood multiplied by, which is, well, essentially going to be the density of the wood, which is going to be 0.8 times its volume, which is going to be L cubed. Okay, this here is just the mass, multiply this by the acceleration. To get the acceleration, we just need to do a bit of rearranging. We can get rid of these, and what we're going to get is that A should be 1 over 0.8. 1 over 0.8 is the same as 10 over 8, which is going to be 5 over 4, which is 1.25. Correct answer is C. 40. A diver at the bottom of the lake at depth D fills a syringe with an ideal gas and seals the nozzle. The piston remains free to move. Volume of the gas in the syringe at the bottom of the lake is 90 cubic centimeters. As the diver returns to the surface, the temperature of the gas does not change. At the surface of the lake, the gas in the syringe is at atmospheric pressure. Volume of the gas is 720 cubic centimeters. What is the volume of the gas in the syringe at a depth of D over 2? Okay, so this here is a tricky one. The first thing I'm going to use is that the temperature doesn't change, so that means that PV is equal to a constant. I'm going to consider the depth D, so I'm going to say PD, multiply this V subscript D, is going to be equal to sort of P1 V1. Let's say that this here is the atmospheric pressure, P1 V1, just after it's at the surface. I can just rearrange this for P subscript D, which is going to be PA, and then V1 over VD. And I've got like all of those numbers, right? So this here is going to be PA times by 720, which is this one, divided by 90. So this here is just going to give me 8 times the atmospheric pressure. Now, the pressure at a depth D, though, is not just hydrostatic pressure. It's equal to the atmospheric pressure plus rho G, and then that sort of H, which is the distance, which is going to be D in this case. So, okay, we now know that PD is equal to 8 times exactly the atmospheric pressure. So we know that rho GD is equal to, 7 times PA. And this is going to become really, really useful in a moment. So the pressure at half the depth is going to be equal to atmospheric pressure plus rho G, and then at some sort of depth D over 2. So because the depth D over 2, we know that rho GD, basically this one here, is equal to 7 pascals. We know that this here will be equal to PA plus rho GD over 2, which is going to be 7 PA over 2, which is basically 7 over 2 PA. So this here is PA plus 3.5 PA, which is equal to 4.5 times the atmospheric pressure. And now we can apply Boyle's law yet again between the half the depth and let's say the surface. So I'm going to say PA V1 is equal to P, let's go with, I don't know, D2, and V, I don't know, at this D2 as well. So what is that going to give me? I'm going to say that VD2 is going to be equal to PAV1 over PD2, which is going to be now going to be equal to PAV1, divide that by PD2 is 4.5 D2. No, 4.5 PA, sorry. So these things can just cancel. So this here is going to be equal to just VA over 4.5, VA or V1, which is 720 over 4.5, which is 720 divided by 45, multiply this by 10, which is 16 times 10, which is 160 cubic centimeters. Correct answer is A. Well done if you've watched this entire video. Good luck on the ESAT.